Okay. Okay, I think we can start now. Good morning and welcome everybody to the Integrated Photovoltaics Conference 2025. I'm Giulio Poggiaroni, and on behalf of ETA Florence Renewable Energies, we have the pleasure to host you in this wonderful venue, house of the Chamber of Commerce of our city. We say for this edition, second edition, Greater Ambition, because we have a program this year spanning over 2 days and with many more contributions compared to last year. And we also have the posters that you can visit during the breaks. The authors will stand in front of them and will be happy to present them. So a very few words to thank our sponsors, Ecoprogetti, Next to Sun, 3S Swiss Solar Solutions, and Standex. And also our official exclusive exhibition partner, Key, the energy transition expert, from which we will hear something very soon. Then, of course, our media partners, PV Magazine Group, Solare B2B, Quotidiano Energia, Energy Tech Review, and Canale Energia. And also our patronaging institution, the University of Florence, Italia Solare, Istituto Nazionale di Urbanistica, Rete IFV, Italian Society of Architectural Technology, and IAS. So, without further ado, I have the honor to give the floor to the conference chair, Professor Francesco Frontini, who will introduce the other speakers in the opening session. Thank you, everybody.
Buongiorno, good morning, colleagues and distinguished speakers and partners. It's an honor for me to welcome here in Florence for the second edition of this Integrated Photovoltaic Conference, a young yet rapidly consolidating platform dedicated to the future of photovoltaic integrated everywhere. I am Francesco Frontini. I'm professor at the University of Applied Science and Art in Switzerland, and I'm director of ISAC, one of the institutes of our department. I'm working on BIPV since a long time, and it's really a pleasure for me to chair this conference. As a chair, I'm very pleased to invite here on the stage our partners, colleagues, and to make a welcome to this conference, to introduce themselves, and to give the value to this incredible event that we are gonna see today and tomorrow. Without taking more time, I would like to invite here on the stage our first speaker, Daniel Valencia is a senior researcher and coordinator of the Seamless PV project. He's working within Tecnalia in Spain. And you know that this conference is organized within this European project that Daniel is coordinating. He will make a short introduction about the key aspect of the project and of the conference. So Daniel, the floor is yours.
Thank you, Francesco, for the introduction. In Seamless PV project, as Francesco said, is the framework of this conference. We are doing different dissemination and communication activities, but also it's a research and development project funded by the Horizon 2020. So we are also working on technological aspects. And in this sense, the project is quite focused on developing different flexible and automated manufacturing processes for different applications of integrated photovoltaics. With these processes, we develop new module materials and PV technologies. And from these PV technologies, we use them and we create different products for vehicles, buildings, noise barriers, and agri-PV. And some other key points, I don't want to extend a little too much the presentation because probably there are some colleagues here working on Seamless PV that will do different presentations, but some key points that might be interesting for you. In Seamless PV, we are also doing training courses. Subsea is working on this, so short training courses, visiting different buildings, etc., but quite interesting. So if you are interested in these training programs, you can check the Solar Architecture webpage. And also, SUBSI has developed the EU Solar Buildings Platform, which is a platform where you can see a lot of BIPV projects. So either if you are interested in see this type of projects, or you are interested in upload your own projects, could be an interesting place. And also, finally, just to let you know that we are publishing public reports that are available in our webpage and also in the Cordis webpage of the European Commission. For the moment, we have reports related with regulatory frameworks, IPV market analysis, and also gaps in standardization, but many others are coming in the following months. So if you are interested in these topics, you can have information there. And I think the next speaker is Paula Gallo. I think, Francesco, maybe you can introduce her.
Thank you, Daniel, for this introduction. So I have the pleasure now to invite to the podium Professor Paula Gallo. She's a full professor in technological and environmental design of architecture, and she will bring us the greetings from the Italian Society of Technology of Architectural Technology. Paola, the floor is yours.
Thank you. Good morning. I'm pleasure to welcome you to this important conference on behalf of the President of Italian Society for Architectural Technology, Professor Mario Lo Sasso, who could not attend today with us. Firstly, we believe that this conference represents a great opportunity to exchange ideas and share knowledge on how to integrate photovoltaics into buildings and in the landscape. In fact, as Italian Society for Architectural Technology, we believe the importance of supporting activities such as this that address the advancement of knowledge in the field of the technical design. A few words about our Italian Society for Architectural Technology, which was founded to establish a broad and inclusive network with the fundamental mission of connected university, professions, and institutions, supporting the culture of research and internationalization in fields related to architectural technology and innovation of the construction world. A mission that I will define as strategic and multifunctional, embracing innovation and progress in the architectural technology sector with the goal of promoting the knowledge, methods, and techniques of architectural technology and national and international levels. For this reason, our society emphasizes the crucial importance of this meeting and support its content, thanking the founder of this important international initiative. This conference therefore aligned perfectly with the institutional objective of our society, which has the following fundamental pillar: connection and research. As our primary goal is to connect university, profession, and institution to support the culture of research in architectural technology in Italy, and events like this encourage the exploring and emerging area of technological innovation in architecture in a crucial field that undoubtedly includes integrated photovoltaics. The second pillar is strategic dissemination. In fact, our society promotes the dissemination of research as a strategic option, and this conference is a direct expression of our desire to disseminate research, and its content connects and integrates with the complementary and related disciplines of design, the soul of our work. The third pillar is multidisciplinary approach. A central vision of our society, which has always been committed to promoting a multi- and transdisciplinary approach to architectural technology, favoring the convergence of contribution interpreted by the different sectors in the building process. And the fourth pillar, and certainly not the least important, is internationalization and excellence. It is through events of this importance, such as today's, that we contribute together to consolidating a culture of internationalization with aims of promoting excellence in the field of architectural technology for environmental design. So the Italian Society for Architectural Technology is proactive in supporting such activities to promote awareness of technical design, So I am confident that this event will provide an opportunity for all participants to exchange ideas and share the most advanced innovation in the industry, exploring new solutions in the field of integrated photovoltaic and thus supporting a market that is ready to face the challenge of the future. So good work for you. Buon lavoro. Grazie.
Thank you very much, Professor Gallo. I now have the pleasure to invite to the podium Giorgia Caprioli. She's project manager at the Italian exhibition group SPA. She will bring the greetings from the Italian exhibition group and will introduce Key. It's one of our exposition partners of the conference. Giorgia, the floor is yours.
Thank you. Good morning, everyone. I'm Giorgia Caprioli, and I work for Italian Exhibition Group. That is one of the most important Italian trade show organizers. But today I am here to present Key, the Energy Transition Expo. That is at the moment the most important Italian event, but also European event dedicated to renewable energy and energy efficiency. Key will take place in March, from 4 to 6 March 2026. Is an annual fair, so it takes place every year, and it is the opportunity to meet exhibitors operating in the renewable energy sectors, but also it is an opportunity to join conferences, workshop, and also session dedicated to the energy sector. So I have a short video, if you can. Thank you.
The Energy Expo Transition.
Key energy has to be like impressive, big, and very complex.
To see the connectivity within the industry.
First word, global opportunity.
With the sustainability,
Connecting.
Oh my God.
It's essential for companies that produce energy.
Per associarsi.
La nostra visione, il nostro impegno.
È diventato ormai una potenza.
Innovazione.
The Energy Expo Transition. The Energy Expo Transition.
Thank you. Okay, sorry. Okay. In this slide, I just summarize some number just to give you an idea of how big is our fair. In 2025, we have more than 60,000 attendances, 14% of them international. We had 1,000 exhibition brands, 30% of them from abroad, especially from 100 country and region involved. Of course, we cooperated with different association, Italian but also foreign association that operated operating in this sector, and we had 195 events and conferences involving 900 speakers. So that is really a big number if you consider that that this is an event of just 3 days. This is our new floor plan for 2026. For the first time, we will open all the pavilion available in Rimini, and we have 7 different sectors. The solar, that is the blue one, of course, the biggest one, but we have also storage, hydrogen sector, wind sector, and then also sustainable city, e-mobility, and energy efficiency. who exhibits a key. Of course, key tell a 360-degree story of the world of energy, involving companies, but also startup, association, organization that operates in the energy transition in various fields like photovoltaic, but also wind, solar thermal, geothermic, hydrogen storage, energy efficiency, sustainable city, electric mobility, and cogeneration. Our visitors is really qualified. This is understood by the fact that the people that join our fair are essentially person in charge, managers, and director operating in services, industries, distribution, and building sector. Our fair, as I said before, is international. In fact, we have visitors from different countries, especially Spain, China, Germany, Switzerland, France, UK, Croatia, Turkey, Bulgaria, and the Netherlands. So if you want, we will see at Key from 4 to 6 March 2026. Thank you.
Thank you very much, Georgia. Very impressive. For sure, we will have the opportunity to visit you next year. We now have a colleague connecting from Brussels, I guess. So Maria gets you. She is a senior expert in the Renewable Energy Source Unit DG RTD at European Commission, and she will give her message and his perspective from the European Commission on IPV. So welcome, Maria.
Yes. Good morning. Good morning from my side, and welcome to the conference. I would like to give with my short presentation the framework or the support that the European Commission is giving to integrated PV and to innovative forms of deployment. If we can move to the next slide, I will explain that, yes, for the first time, with the EU Solar Strategy, which was released in 2022, the European Commission emphasized for accelerating the expansion of PV, emphasized the innovative forms of deployment. As you can see in the slide, with the EU Solar Strategy, the aim is to expand or to accelerate the expansion actually of photovoltaics in general, so that by 2030, we could install almost 600 gigawatt AC of PV in the European Union. So one of the initiatives, among many others, for example, you see the decentralized rooftop deployment, so the rooftop initiative, but among them, for the first time, we see the innovative forms of deployment. And when we say innovative forms of deployment, we include all the integrated forms of PV, so integrated in buildings, in vehicles, integrated in infrastructure, but as well agri-PV and floating PV. So the Commission promised in the solar strategy that we will carry a study on which are the obstacles for the expansion, to accelerate the expansion of innovative forms of deployment, to find also the good examples of what the member states are doing in order to promote these innovative forms of deployment. And then it would release guidelines to all member states on how to accelerate their deployment. More or less at the same time, or a little bit later on, with the revision of the Renewable Energy Directive, or the RED III as you see it, which aims in general and which sets a binding target for the share of renewable energy in the total energy consumption by 2030, and this share has to be 42.5% minimum. It set another indicative target of at least 5% of newly installed renewable energy capacity from innovative renewable energy technologies. So this includes all these forms of the innovative forms of deployment of PV as well. So the study that was promised has been carried out, and then at the end of the study, there is a Commission notice on innovative technologies and on innovative forms of deployment, which was released in July this year, 2025, and it gives guidelines to member states on how to promote and how actually include in their energy system these innovative forms of deployment and of integrated PV. If we move to the next slide. No, the previous one, please. Yes, here. The next one. Yeah, there, yes. So speaking from, as you see, I'm working in DG Research and Innovation, so for Horizon Europe program. And with the Horizon Europe program, we want to support the innovative forms of PV deployment, so integrated PV, including Agri-PV and floating PV, because besides the regulatory, for example, obstacles, or the standardization obstacles, the obstacles that all these integrated forms face, but each one of them faces as well. So because there are different technological still problems that need to be overcome in order for this integrated PV to be massively used. So we have launched with Horizon Europe a number of topics in order to support and to develop the various forms of integrated PV. Building integrated PV, vehicle integrated PV, PV integrated in infrastructure, as well as agri-PV and floating PV. In addition, we have also supported the topic, well, with all the topics, we insist on standardization procedures, or that projects that derive from these projects develop as well standardization procedures for the integrated products. And there was also a topic on manufacturing of automated and flexible production lines of integrated PV. You see the topic in the slide, from which seamless PV resulted with another couple of projects. Now, because it is important that integrated, or the importance of integrated PV is high, and in the European landscape, integrated PV and innovative forms of deployment of PV are important. We will continue to support with the work program 26-27. We will continue to support these technologies. And there will be again a topic on manufacturing, on flexible manufacturing or suitable manufacturing of integrated PV products, as well as another topic or other topics that will support the development of agri-PV systems and offshore nearshore PV systems, so that the projects develop first-of-a-kind solutions for energy production from these systems, which are, of course, renewable, which respect the environment, and which respect the water resources and biodiversity. So all in all, this is my introduction, and I would like to wish you with this a fruitful conference and very engaging and interesting presentations and discussions. Thank you, and bye from my side.
Thank you very much, Maria, for being online with us, and to all speakers for giving your welcome to the conference and your perspective on IPV. I mean, you are making a really valuable job in order to promote and push forward the technology and our energy transition. I am delighted to stand here and officially launch this second edition of the IPV conference. We met in a city that has historically fused art, engineering, urban design, and innovative thinking. Florence is the birthplace of Brunelleschi's structural revolutions, with his famous dome and its innovative structure able to solve the problem of the scarcity of wood for traditional roofs by creating a self-supporting solution. It's also a city that hosted Leonardo da Vinci, a multidisciplinary genius, able to perfectly combine artistic creativity with scientific rigor, But Florence is also the cradle of the architectural experimentation of the Renaissance. This context is more than symbolic. Integrated photovoltaic, IPV, requires exactly this combination: technical competence, design sensitivity, and systemic thinking. Photovoltaic deployment is accelerating at an unprecedented pace, becoming, at least for utility-scale PV system in many countries, the cheapest energy source. As we heard before, in 2023, the world installed approximately 440 gigawatt of new PV capacity, and 1 year after, in 2024, more than 600 gigawatt has been already deployed. But interesting to know that projections suggested that annual installation could exceed 1 terawatt by 2030. This exponential growth, however, brings new challenges, as was previously outlined. Land availability, grid integration and the need for decentralization and demand-side generation, environmental constraint, but also public acceptance and training of different stakeholders and experts that are increasing day by day to be able to answer the growing demand. History teaches us that challenges ignite progress. Humanity has always risen to the occasion, transforming obstacles into catalysts for advancement. Think again of Brunelleschi and Leonardo da Vinci. It is in this context that the integrated PV becomes essential. Unlike utility PV, integrated PV does not compete for land. It exploits surfaces already serving structural, architectural, agricultural, or mobility functions. And it generates energy exactly where it is needed, reducing load on distribution grids and enabling self-consumption. Across Europe, but everywhere, the technical potential for integrated photovoltaics is extraordinary. Several studies exist, such as, for example, the recent study of the Becquerel Institute, partner of the Seamless PV project, that estimated a gross technical potential of photovoltaic in building only in 2024, considering what is already present, what is already there, over 64,000 kilometers square, where facade account for about 2/3 of this surface. Renovation and new construction can increase this potential significantly. Road and rail infrastructure, noise barrier, parking structure, industrial facades, and also logistic warehouse collectively unlock hundreds of additional gigawatts. Agrivoltaic, as we heard before, depending on the configuration, could also add from 500 to 700 gigawatt of dual-use potential only in Europe, while preserving or even enhancing agricultural productivity. This is the scale at which integrated PV can contribute to the energy transition. Several technological advancements now make integrated photovoltaic possible in ways that were simply not achievable a decade ago. At the level of cell and module architecture, just to mention a few of them, we now have shingle design that allows seamless, visually continuous surfaces, eliminating the strong visual discontinuities that once limited architectural integration. At the same time, the rapid progress of perovskite silicon tandem cell, now approaching 30% efficiency in laboratory conditions, signal a future where integrated PV can deliver higher output, even on limited and complex surfaces. Equally important developments are taking place in material and encapsulation systems. Custom laminates, lightweight composite structures, and advancement encapsulation technique enable PV modules to meet both structural and architectural requirements. Colored coating, photonic structures, and semi-transparent solution now allow designers to control aesthetic appearance, light transmissions, and spectral selectivity, opening up application in glazing and architectural settings where light quality is crucial. On the manufacturing side, within the industry, IPV is moving toward the paradigm of mass customization. Pre-laminate and modular subassemblies allow high adaptability while maintaining industrial scale production efficiency. Digital printing, structural patterning, and automated production lines create new possibility for bespoke architectural integration. This shift brings the gap between laboratory innovation and real-world construction practice, making IPV economically and technically viable at scale. Finally, digital integration is redefining the design process itself. BIM environments, parametric modeling, and digital twin technologies enable architects and engineers to integrate energy performance directly into the early design phase. Dynamic simulation allows real-time assessment of shading pattern, thermal behavior, microclimate effect, and crop light interaction in agrivoltaic system. Together, these technological advancements represent the foundation upon which the future of integrated photovoltaic is being built, enabling PV to move from a purely energy-generating device to a multifunctional structural and design element capable of reshaping our built environment and, of course, creating new opportunities for jobs and innovation. These trends are all visible throughout this conference. Our program is intentionally structured around 4 major integration domains. In architecture and building, the program explores building integrated photovoltaics through new development, operational experience, and reliability studies, addressing facade system, roofing solution, fire safety, durability, material performance, and real-world case studies from research institutions to industry leaders across Europe. Through infrastructure and urban application, we examine how parking structure and roads, noise barrier, and other built elements can evolve into productive energy system. The field of agrivoltaic focuses on advanced system, exploring crop light interaction, vertical configuration, sustainability assessment, and land use strategies that balance energy production with agricultural performance and also landscape protection. Under transport and mobility, integrated photovoltaics takes center stage with industry experiences illustrating how PV is being embedded into vehicle through advanced material, lightweight solution, and practical implementation in real mobility application. Beyond these 4 pillars, the conference deliberately leaves space for what comes next. Through posters, presentation of case study, and of course, cross-disciplinary discussion, new idea, unexpected application, and emerging markets may surface. This 5th dimension, the space of exploration and future potential, is where the true value of bringing diverse expertise together becomes visible, allowing integrated photovoltaics to expand far beyond current boundaries. In order to express this 5th dimension, we need to be convinced that the success of integrated photovoltaic is not merely a technological challenge. It represents a profound cultural transformation in how we conceive our built environment. This shift calls for a new collective mindset, in which energy, design, and function are inseparable. Yet this change cannot start only with today's professionals. We must begin with the younger generation too, with children, students, emerging designers, future engineers, and young planners, encouraging them to think, design, and speak with photovoltaic in mind from the very beginning of their education. Just as past generations learned to conceive buildings around structure, light, and form, future generations must naturally include energy generation as an intrinsic design parameter. To make this vision a reality, dialogue is essential. Each discipline brings a vital perspective, and only through the convergence can photovoltaic truly become a natural and meaningful component of our living environment. This is precisely where the IPV conference positions itself as unique. Coming toward the end of my talk, I would like to express my sincere thanks to Angela Grassi and the whole ETA Florence team, in particular Giulio and Heinz, for coordinating and co-organizing this event. Our scientific and technical committee, our sponsor, they do have also booth and exposition outside, our institutional partner, including the European Commission, and all our media partners for amplifying in this work. But most importantly, thank you, the participants. You are the researcher, engineer, architects, manufacturer, and policymaker building the future of integrated photovoltaic and of our society. Over the next 2 days, I would like to invite you to challenge assumptions, ask difficult questions, share lessons learned, and build collaboration that extend beyond this event. For the energy transition to succeed, we need to unlock every opportunity to integrate renewable energy into the very fabric of our surrounding, moving beyond standalone system. It is how we move from adding PV to designing with the PV. It is how we turn our built environment into our energy infrastructure. And it is how we ensure that the global energy transition is not only fast, but harmonious, resilient, especially responsible. I'm delighted to officially open this Integrated Photovoltaic Conference 2025 here in Florence. Thank you, and I wish you all an inspiring, productive, and technically enriching conference. So we don't have a break if maybe we need it, but I would like to welcome on the stage our first chair of this session, my colleague Pierluigi Bonomo, who will moderate this first part of the conference, having also 3 relevant speakers: Elisabetta Trezzani from Renzo Piano Building Workshop, Paolo Cresci from Arup, Italy, and Professor Mario Botta from the Politecnico di Milano.
Good morning. Hello, everyone. Very good morning, everyone. Thanks also from my side to the organizers especially for trusting me with this first session. It's an honor to open the conference, and also it's a great pleasure for me to have this first session. And it's a good moment because still everyone is awake, very energized, and ready to start with many topics that are promised for today. So thank you all for being here. I'm Pierluigi. I'm a senior researcher and BIPV team leader at SUPSI in Switzerland. Essentially, I spend my days trying to transform ordinary buildings in solar ones, and essentially with one main goal: trying to make them look like still buildings, and on a good days also as architecture. So thank you, Francesco, also for your message and for your kind introduction. You mentioned the Renaissance, and that's true that we are immersed in history here in Florence. And art and history teach us what's the power of innovation, and especially the courage of transforming challenges of our time in innovation, but also, I would say, into architecture and beauty. Too often, as experts, we start from technology as a tradition, and we try to solve all the problems that we have around it. And as you see from the title, this session try to focus on the use of photovoltaics in buildings, also with a challenge, I would say, or a provocation. Not PV everywhere, but design everywhere. So if you can take a look also to the slides, I will. Okay, here. I started with this first provocation, and I wanted also to share briefly a few pictures. This building, I took this picture 12 years ago, more or less, in London. It's a building in Chelsea. And this building really surprised me at that time and convinced me to stay in BIPV research and development. PV experts usually hate this picture because, as you can see, we have colored cells, we have shading, we have a tree blocking irradiation. So for sure, it's not the conventional and the best situation we can have for energy production. But architects still find it inspiring and interesting because imperfections of this building make it alive. These crystals of the solar cells appeared to me like artificial solar leaves changing color under the sun and living with the natural ones. So essentially, I strongly believe that the dialogue among disciplines is really essential. At SUPSI, I found some time ago a very fertile ground for this approach. So we are focused on a very applied-oriented research, strongly linked with industry, with professionals, and the real market. And in this context, architecture and technology are really close and go hand in hand. You can see here in this picture the material library of our faculty, where you see the PV panels really in the same place where we have all the other construction material for buildings. So essentially, our idea is to let students grow up with the idea that PV is also out of the laboratory and is ready for their ideas of future architecture and future cities. The history of PV in buildings is quite long. We studied it, and we also contributed a little to this amazing journey that took almost 40 years. More information on our website and also with some interesting material. Francesco, in his message, mentioned a cultural gap. At SUPSI, as also Daniel introduced, we are particularly focused in developing a research avenue dedicated to inspire, to educate, and train new generations of students, but also professionals. This is a key part also of the project Seamless PV, which is hosting today IAS, and we believe this is an essential aspect of collaboration with key actors. This session will explore how solar can become part of this design narrative. We will have two main parts. In the first part, our speakers will present a project, the Campus Goccia project, and in the second part, I will have the pleasure of moderating the discussion with them to explore more closely their vision and their approach in using solar in the projects, in architecture, and in their way of thinking architecture and cities. So in this session, we will really try to see solar as a part of a design narrative, not just as an energy device, but really a source of meaning within the architecture and the city concept. This approach really resonates with Renzo Piano Building Workshop idea of architecture, where experimentation connects concept, detail, and construction. Through their unique, inspiring work with sun, with light and lightness, their workshop established a global reference in making architecture and a unique approach over time. So architecture is for sure more than construction, and especially is the way to shaping spaces where people live, gather, and belong. So I'm therefore very pleased to welcome and to thank Elisabetta Trezzani for accepting our invitation. She's a director and partner at Renzo Piano Building Workshop, and she has led major projects like the new Winnie Museum in New York City and the Harvard Art Museum in Cambridge. She has also curated, I know, several exhibitions for the workshop, and she's currently overseeing the project of Campus Nord for Politecnico di Milano that we are talking today. As you have seen, we have titled also the session Solar as a Way of Thinking, because we wanted to highlight that designing with environmental consciousness today means embracing complexity, means connecting specializations, and this is what since 1946 Europe is doing by really uniting architecture and engineering with a strong social purpose in their lesson, with what we all know it's the revolutionary idea of total architecture. And this is really an approach where collaboration, human-centered approach cross together and live with disciplines. So I'm really happy also to welcome Paolo Cresci. Thanks for joining us today. He is the Associate Director at ARUP. He is the Head of Sustainable Development for Italy and also the European Urban Energy Leader for ARUP. So he leads many multidisciplinary projects with a strong sustainability accent and focus, including the project we are talking today, the Campus Goccia, where they are overseeing the sustainability aspect as a consulting. So thanks for joining today. And I also said that today we wanted to give space to a special project, truly unique, I would say, and behind every good project, alongside architects and engineers, there are also great clients, I am convinced. And Politecnico di Milano, in this sense, is leading a quite unique experience of reconverting a 32-hectare of the city of Milan in a new hub for education and innovation. This is an ambitious and incredible benchmark, confirming the commitment of their vision for future generation. So a very welcome also to Mario Motta, who is Director's Delegate to Energy Transition for Politecnico di Milano, and he's full professor of energy and also head of a laboratory in Polyme. So thanks a lot, Mario, also for helping us in shaping this session, and welcome also from my side. So I talked, I guess, already quite a lot. I'm excited to hear directly from our speakers more details on these remarkable projects. So I'm really pleased to hand the stage to them. I guess, Mario, you will start, and then Elisabetta and Paolo. So I want to thank you once again for joining us today and hearing from you. So thank you, everyone.
So, good morning, everybody. Thank you very much, Ferrucci, for the introduction. I'll try to so following what Pierluigi was saying, we're going to speak and give you an idea of a project where Politecnico acts as a client. And I'll give you, if we can make our slides starting, this could be, okay. So do I have to do it from here? No? Okay, here we are. So it's let's say the background situation is that Politecnico di Milano is in this new round of governance, which started 3 years ago, put it very much sustainability at the core of its activity. And let's say the aim is to be a solid, recognizable, reliable reference point to lead by example on these issues. So we started a very significant activity of planning our work around sustainability, with a strategic plan which just ended and a new one which is going to start from the 1st of January 2026 to the end of the rector mandate. And this is mainly due to the, let's say, with the aim to involve the overall community of the university. I mean, you know that most of you probably don't. So Politecnico di Milano is the largest technical university in Italy. Their students from engineering, architecture, and design study, and the overall community is about 60,000 people. And there are 55,000 students, and the rest is staff. And let's say the overall aim of these planning activities is to put the core of the sustainability at the core of our activity in all the expressions of the university life. So in the education, in the research, in the relationship with the society around us. And in this background situation, we started to plan, let's say, on the main pillars. And when I speak about sustainability and what we are going to speak about today, we are at the Integrated Photovoltaic Conference, it's mainly energy and decarbonization. But it's actually the idea, and this is linked with what we are going to say all through this presentation. It's actually to work on the sustainability in a wider way, having an impact as well on the social life around the university and relationship within the universities and the community of the people who are living there. This means having sustainability working mainly on 5 pillars: people, education, research, social responsibility, and then the infrastructure, so campus and environment. What we are going to look at technically here is mainly the work that we have been doing on the infrastructures. So basically energy and decarbonization, which actually includes as well circular economy, sustainable constructions for the new buildings, and the mobility, which are, let's say, the energy and the mobility are the 2 main areas of CO2 emissions for our university. Let's say, for what the energy decarbonization concerns, our activity has been concentrated mainly on reducing the amount of energy that we need, so having energy efficiency, and integrating renewables, so energy produced from renewables. With a final aim, that is the one that you see there, to reduce our footprint, our carbon footprint, all along the way of our plan, medium and long-term plan, which foresees that in 2040 we will be carbon neutral. We've been quite successful, let's say, in the energy consumption reduction and building renovations. We had some progress in the integration of renewables. I'm going to show it to you in a second. We made some steps, and as you see, we had already a reduction of the emissions compared to 2015, which went above the target that we have at 25%. Actually, this is the path of the decarbonization that we had in mind. Let's say we, as you can see in this diagram, it's slightly easier for us to reduce the emissions which are linked to the energy, which is the orange line on that diagram. It's slightly more difficult to work on the mobility. Mainly the mobility for us is the emissions linked with the fact that people travel to the university and go back home from the university. And we don't have very many tools to convince people to change their way of commuting to the university. But I mean, on the energy part, and this comes the main object of the discussion today, we did already a significant step, and actually from the 1st of January 2026, I'm going to tell you in a moment, but I mean, the idea is that we are going to buy only electricity coming from renewables through a PPA, a power purchase agreement, for what is needed apart to the energy that we self-produce on our campuses. So the key results of our planning, of the activities which were planned, are listed in this slide here. We have already about 2.6 megawatts of photovoltaics installed by now from the 2015, and we plan to have 100 megawatts in 2026. And this is before Campus Nord project that we will see will give us a significant boost in the production of electricity on site through renewables. As I was saying, the rest of the electricity that we do not produce locally, from the 1st of January, we are going to buy it from renewable electricity producers. We have already a reduction of the emission, which goes slightly above what we had as a plan. We reached 31% of the CO2 equivalent emissions reduction to 2015. We have 2 plans, pretty strict actually, a mitigation plan and an adaptation plan, with all the actions that we want to implement, which are including technical actions, and giving us as well a perspective for the investments that the university has to carry out in the next 15 years. The last 2 points of this list are one action that I'm pretty proud of, that we have been the founders, together with the municipality of Milan, of an energy community which actually involves the overall citizenship of Milan. I will give you some details later. And the project that is the objective of the discussion of today, where we act as a client, which is the new campus north in the north area of Bovisa, that we call La Goccia, and which includes, let's say, from the points of view of the discussion that we are doing today, a very large PV system and a significantly innovative energy system based on geothermal energy, which guarantees near zero operational carbon activity. I'll give you. I'll pass the stage to Elisabetta now. And yes, thanks. Yes.
Thank you, Mario. Thank you very much, and thank you, everybody. So just to give just where we are. So the area La Goccia, it's in the north area of Milan, in the direction of the airport Malpensa. And it was a full industrial area in the 60s. And this industrial function was dismissed around the 80s, and this is what he became. It's incredible when you completely abandon a site and the nature really take possession of everything that it was left. And it remained like that for almost 40 years. There was many projects involved in this area, but nothing really happened due mainly to it was a really contaminated site. So the Polytechnic of Milan already moved to this area in the 90s, I think, when mid-90s, exactly, and building already what is called, and you see here in this plan, Politecnico La Masa, and after with that it's mainly engineer school. And on the other side of the railway, it's created instead the Politecnico Durando, that it's more now the design part. The area, it's called Goccia because the railways really shape this area. And when with the Politecnico, we went the first time to visit the site, that it's completely, closed and nobody was able to enter. We found ourselves in a real forest. I'm not joking, it was almost impossible to walk. With some left industrial building, quite interesting. So the first, as architect, the first idea that it came to us was how we can save this nature. You know, we should be able to build a future campus, but to try to save as much as possible this forest. So the first, it was not what to design, but how to save this incredible opportunity. And so it was, we started to talk with specialists, because we are just architects, we need people that know better than us other item, to understand what was possible to clean the site without destroying this type of nature. And building this new campus, the great idea was that it's not just educational spaces that our client asked us. Mainly was to create an innovation hub with different function, because one of in Italy the issue that we have a very good education, but we have less opportunity just after we finish the school. So how we can try to keep our young people and develop their idea, and how to enter in the world of working without need to go in other places. And when you start an interesting process in a way, it's when the city of Milan understand which type of opportunity they were having in this part of the city, and so wanted to be part of this experience, and decide to move here, what is called here Scuole Civiche, that it's a school for cinema, theater, and music. And it will be quite a bit of a new experience for students to be next to different type of function. Yes. And the other things that, it was in Mario's slide also, the issue of mobility. The area has 2 main rail stations. But so we put our effort also to improve, and we hope we will do it, to improve these 2 stations from a safe point of view, from a lightness and light point of view, so to make sure that in the future, when this campus will be done, that it will, attire so many more people, that the people will start to use less cars. We are not designing many parking. I'm sure we will make people not happy at the beginning, but we need to start the process somewhere. As you can see here, at the end of the day, we create almost 20 projects. It's a very, very complex project. And all the Italian institutions were involved, from minister point of view, the city of Milan, the region, Lombardia. And this project happened only because each one of these institutions decided to sit with us, with Politecnico, with our consultant, around a round table to discuss and to put their knowledge and their dream all together. Project like that doesn't succeed for one group of people with just one client or just for the architect. If you are not a group that want to work together in the same direction, this thing doesn't happen. And this was pretty, interesting, not always easy, but we made it at the end. This quickly to give you an idea of a different function that the client asked to include in this campus. So we will have, educational spaces that are the orange one. We will have a startup incubator that are the pink one. Some residential for students that are the blue one. Some offices and what I see the scuole civiche. The yellow building are the existing building, and the one that you see here are all protected. So we are doing a restoration of the spaces. And the nice part, it's this building help us to create the layout of the ideas of a campus. There are the two round yellow are, let's say, probably the existing iconic building on the site that are two gasometer, that they will be renovated and are already in construction right now. And you see the red line horizontal that we create the idea, and this is something that we found already in the place. So there was many indication already on the site that we use as a reference, and it was almost already designed, this campus. We decided to design very simple building because here we are not talking about one special building, one iconic building. This is a way of life and a way of living for a campus that we were trying to create. And here is the main axis of a campus with this building that they will have a ground floor completely transparent. The building is only 3 floors because there was this idea of like that they will not go higher than the trees and the nature. So you have a feeling to be in the nature and to create a space with light. For anybody of you that know a little bit our architecture, light for us, it's probably the most important material that we try to create in our architecture. So the connection between the building, this feeling about open and transparency, not just physically, but mentally, like transparency of idea, it's really what we try to create for the campus. And the light create, with the nature, create this sense of reflection and, I can use the word beauty in a way, for this type of spaces. And these are the different type of functions. So the buildings are quite similar. They just change due to the different function, but are again quite simple. The two gasometer are like, as I mentioned, a quite iconic element. And we design also an aula magna of 1,000 people that create a kind of dialogue with the two gasometer. And we take a reference from other projects that we did in United States. For example, at Columbia, they always have a kind of open space where the students, happen the graduation. But we hope that in the future it will be used by the city of Milan. The two gasometer, as I mentioned, are already in construction. The taller one, it will be again startup and some heavy laboratory. The lower one, it's dedicated to sport. And this is the space that I was mentioned. So in between the aula magna and the gasometer, it's almost 90 meters diameter. And we hope that, this will be a place not only of the university, we hope, but I don't know, for concerts, to bring the city of Milan inside the campus. It's a flexible aula magna could be divided in 4 different spaces. And this is, as I was mentioning before, these are the existing building. And with the Polytechnic, it was quite interesting. We try to give them different function, like the one in the center next to a central piazza. This will dedicate to food, where the students can sit and stay all day and collaborate and working and study, enjoying. And this other building will be dedicated to art, to include in the STEAM discipline the art of art, because it's, you know, contamination in arts and discipline. We really believe it's a great opportunity. One to the AI discipline, and we will have a greenhouse that will support the study on the foresta, and this water tank that it will be the only element that is existing, need to start renovation, but it will be the only element that it will go up above the trees, and we create a kind of meeting room, special meeting room. And this is a view from the park to the campus. As you see in some images, so 3 elements were really important for us in this campus. So the ground floor, the level where people live at the street level, all the spaces are public and open. The ground floor of each building doesn't have a fixed function. It will be open for students, for staff, to meet people, the nature, and at the end, this, you know, what Mario was telling you before, the objective of the Politecnico. So these 3 elements are the 3 elements for us that keep the campus as a unity element. And so the idea came to take reference from the existing building that has a shed roof, and to create a roof that covers all the new building with a reference of a shed, and create a big solar capture that, you know, when we started, we didn't know, but through all the project, you know, reach the objective that the Politecnico need to be. We made so many studies, and so for us it's important to as even Pierluigi mentioned, you know, to create as a material and an integration in our, let's say, detail. So this roof started with model, it's a steel structure with glass panel where photovoltaic cells are integrated in the glass pane. And the idea was to connect all these buildings, so this roof fly above a building, is extend outside in each direction to like protect the sidewalk around the building, but it goes also above some open space. It's a space frame that is connected with the structure of the building, 6 by 6. And we study all the connection of detail you see here, because, you know, every detail play with the light, and, you know, to create shadow and element. And this is the first mock-up that we did more than a year ago. This is more a visual mock-up, and this help us to, you know, how make the layout of a cell inside the glass pane, to understand how much light was passing through the roof, and in which location, like when you are above the building, where you are above open space. So we study all of that. because this is the center of our project. Create a place for people, for the students, for the staff, for the city of Milan, where people living here understand the importance for our future of the nature and of the energy consumption. Thank you very much.
So good morning, everyone. And yeah, I imagine there will be a series of questions, actually. Yeah. So we are aware. And so let's make a further step. And so thanks to Pierluigi, to everybody for having the possibility to join Mario and Elisabetta in explaining a little bit the project from now, not a very technical and detailed point of view, but of course moving further in understanding how sustainability energy, the targets the Politecnico had and as an organization, but also specifically for this project. And as Elisabetta described, at the end, the solution that the project is, talking about, especially the energy and decarbonization target, how we deliver this project and optimize the project from this point of view. But of course, sustainability has to have an integrated framework to guide the design team, the client, everyone, all the stakeholders. And so we don't talk just about energy. We don't talk about just, zero carbon. And the focus was also, of course, on materials and technologies and reduction of embodied carbon, circularity way of construction, looking at climate change, how's the impact of future climate scenarios can impact in terms of, increase of energy or risk of other natures, how the social and community components plays a role. And I'm not going to get into this too much, as Mario and Elisabetta before explain how much was the focus to create this open and integrated way of working, living, and studying for the students and for the whole city. And as we are here in this context, how innovation was actually one of the key drivers of the whole project. If we have to identify 3 key pillars, so they are the zero energy target. There was a zero energy target. There was a challenge there. And so innovation was definitely needed for reaching this target. And the third point is, though, that we don't have to forget health and well-being in the wider, sense and concept it might be. The zero energy target, therefore, requires an effort. And the effort is such that when you raise the bar, but also fix a target, then things change. So you gather all the people that are working together in order to reach this target. And this is a very difficult target, of course. But that's basically the fil rouge that is, from at least this aspect, leading the evolution and the development of the project. And I'll try to give you some more details on that. And of course, when we talk about zero energy, it's not just a matter of technologies, as we are saying here today, right? It's, of course, playing with all these, there may be others, but we here are highlighting 9 key components. Some of them are kind of technical, others are really strongly connected to design. So having an organism, an ecosystem that is a kind of reacting. So what's the role of nature into that, right? What's the role of these green elements at the ground level? What's the role of this mega roof in terms of balancing, the effect of different climate conditions, especially, of course, the summer one with heat waves and so on. And what's the nature of the relationship between indoor spaces and outdoor spaces, that this leads to the point of, as we will see in a moment, what's the role of everyone, not just the Politecnico of Milan, not just who is going to operate and manage this very complex ecosystem, but actually the role of each of us, students, the people living there, the people working there. So everybody's involved in the net zero target, as we will see in a moment. But if we want to split a little bit, break down the different components, that's a very simple diagram that is basically describing how there are 5 key components. They all interplay together in order to reach or try to reach the zero energy target. And this is about, as I said, the nature-based solutions are playing a role here. The buildings themselves have to be optimized, of course. And optimization of buildings is always a very complex matter, depending on the functions inside, depending also on new elements, like this mega roof is changing a little bit all the, the traditional way of thinking, right? You don't have just massings that are exposed with certain direction, but you have something that is influencing the overall behavior of the system because just you got this big, huge element that is projecting shading and so on. But also we need to ensure that the quality of life indoor and outdoor is good enough. We will see some modeling afterwards. And then, of course, the systems. So, as Mario said, here we have one of the largest ground source heat pumps. When I say ground source, I mean water loop water source heat pumps, 900 liters per second that is serving the whole campus. So basically, the generation of heating and cool is actually already decarbonized. And PVs, as we will see, are playing the role of offsetting, generating enough energy for offsetting the carbon required by the campus in terms of operational, of course. You see here some numbers. So more or less, the roof is over 30,000 square meters of PVs, reaching a 4 megawatt peak of installed capacity. As I said before, the balance between the different components is a very delicate one. So if we isolate the optimization of the energy generation, of course, I guess everyone is looking at, at the section, at the setup of this kind of peculiar way of having these different panels, big panels, the spanning of the panels, the kind of proportion is not actually a standard one. So every one of you, I see you nodding, are wondering, that's a strange way of making a PV. And I'll try to explain why. And so it's kind of counterintuitive, right? That this is the right way of doing such an installation. I'll come back to this afterwards. But here you see 4 key elements which are deeply interconnected together in order to find the balance about the 3 key components of, optimizing the solar production, optimizing solar shading, but increasing daylighting. Increasing daylighting is a technical factor, but as Elisabetta said before, for Renzo Piano, for every one of us, for all the people that will be living and working there, studying there, the lighting is not just a matter of lux, it's actually a matter of quality. And that was an incredible, soft balance to reach. And we spent almost 2 years in working on that one. And still working, actually, on the optimization of this. Of course, as I said, working at building level means in order to reach net zero, in order to reach net zero energy, net zero carbon, that's one of the big challenges, right? In which renewable energy and renewable solutions like PVs are playing a fundamental role. But we have to push a lot the way that we conceive and design buildings, not just the envelope, but also the systems. And we look at basically all the possible solutions and always you have to find a balance point in which you want to improve as much as you can everything, but then there are some balance that you have to achieve. It's of course a matter of money, but sometimes it's even limited to the way of, bringing together all the potential technical solutions, and all of them, 100% of all these solutions can work together. You can see here some of the elements that we work on a lot, focus on a lot, in order to optimize as much as we can the energy performance of the building. That, by the way, just a little point on this, we reach numbers that when you compare these numbers to the, benchmarking with other projects, I'm not talking just about, campuses and universities, but also, because as Elisabetta explained, we got different functions. You might have like, some, residential building are there, office startups buildings are there. So the energy performance have been really stretched to the minimum in order to reduce the energy demand of the complex. And that was a big, big challenge. And I think they are also very, very, it's a very relevant example also on this aspect of the challenge that we are facing in our net zero journey. And then I touched the role of the people. We all know this is one probably of the bigger challenges that we have at the moment. And I think projects like this offers the possibility that they start with a clear vision. They have the right, client, like Polytechnic of Milan, very, educated, technical, that will manage everything. And this is one of the, opportunities that this project offers, which is about, trying to, what we face normally in projects, the fragmentation of the old supply chain and the process, right? I mean, you conceive a building, you design a building, you then build a building, and someone else is going to operate the building. There are so many fragmentation throughout this process that is really difficult to say, okay, that's the performance we want to achieve. This is going to be the performance in reality. There's a gap, the performance gap, which is huge normally. And here, this project is also an example of say, okay, we've been working a lot with piano, of course, when it's a piano building workshop, but with the Polytechnic of Milan, with all of them, in order to define really what are the users of this campus, what they're going to do, what time they're arriving, what happen, looking at the real behavior of the campus and how much we can improve the way the campus will be used. And I think this is a never-ending problem, a never-ending activity that the Polytechnic of Milan will have to carry out for the entire life of the campus. So let's get to the PV roof. And as Elisabetta explained, that's the kind of setup. So there's a direction which is driven by the existing grid and existing premises and buildings that are there. So there are some fixed elements. And and so I mean, this is just one of the snapshot of all the different, modeling and analysis that we did in terms of understanding, of course, the yield of this system, how much, even sometimes, it's kind of obvious now what you are looking in terms of color. I mean, it's quite, intuitive. The point is that you are dealing with something which is not really standard. And so you have, and this is another great lesson learned. Now, when you face something that this is not, kind of standard, then you have to learn a new way of looking at things. And if you look at this as a single element, just a series of panels that basically replicate themselves throughout the roof, that's, the first kind of instinctive reaction. But it's not like this. It's much more complex than that, and I'll show you in a moment. But as I said before, that's the element one, energy generation optimization. The second is, what's the role of this mega roof in terms of effect on the thermal performance of the envelope, shading, solar gains control, and so on. So that was another element of, of course, focus. And this means, of course, playing with how the buildings, how the function inside the building can be optimized thanks to the roof. And the third element, as I said, is daylighting. And again here, we are, of course, outside the building, but inside the building, the functions move around in order to get the light and put the functions that require more light and put other functions that require less light in other part of the. So it's a way of rethinking the way that maybe you can, deliver a building that might be different compared to a normal building without a mega roof. So it's all this part of a journey that we explore together. And then the space frame. So let's have a look in more detail. As I said before, there's not just one type of panels. There are actually more than one. There are, of course, active panels for the majority. In some areas, the panels are not active, of course, in which they don't get any light. But but this is a small portion. Of course, you can see, you know, like the blue ones, the small portion, those are not active. The rest, they change. They change depending on the position. They are fully exposed to the sun. They are above the buildings. They are in between the buildings, above the outdoor spaces, and so on. And then we started looking at how much these panels can generate. And let me say something. Sorry, I go back once again. In this configuration, and I go back to, you know, the initial big question mark, which is why this shape, this setup of the panels. The target was zero energy. When we think about PV in terms of, you know, optimization of producibility, no, not production, but how much each square meter of PV generates, that is normally the driver that drives us in optimizing PV panels, which is correct, right? For many of the installations that we saw before in some of the pictures, actually, you have to optimize because the putting PVs along, you know, a linear infrastructure or putting on agrivoltaics, at the end, those PVs have to play just one function, optimizing the yield of the production. In this case, the zero energy target was the driver. So we had to optimize the overall production of the systems in order to reach, I'll show you some numbers in a moment, in order to reach the balance between the energy demand of the complex and the production of the building. And just to give you a little bit of a flavor, if you know, play with the normal standard setup of installation of PVs, 30-degree tilt, you know, almost to, the normal distance between the height and, you know, and the width between the different modules and so on, we would have reached almost half of the energy generation that you are reaching with this installation. So the point is, if you want to optimize the way that a single panel generates electricity, okay, then the standard rule is very well known. If you want to reach the maximum energy production, then this solution is looking at that specific goal. That's the thing. But then you can reach that goal by playing with the optimization of the different, tilt and length, and playing also with a transparency, a reflection, because the PV cells are of course two sides active, and so also taking into account the mutual reflection between the modules and so on. The optimization inside each of the vela, inside each of the big panel, was again another step-by-step activity in order to play with the effect that Renzo Piano Building Workshop wanted to achieve in terms of daylighting. As Elisabetta said before, this is not just optimizing the PV cells per se, but is actually finding the balance of the effect that all these elements and also the way of treating the cells and the glass in a way that the final effect underneath the roof is actually the ones that we want to achieve. Here you can see two different configurations. And of course, every project goes from preliminary to definitivo to executivo and moves up, and now is on site. So further optimization are in place at the moment. Then you see that in this step from executivo to a further step, then the optimization of the density of the cells in certain areas, as you can see in the right-hand image, was such that we got an increase of production again without, a little bit, of course, of producibility increase again without losing any, performance in terms of daylight. So this is a step-by-step, very, very constant way of improving things. So you see here the first, type of panel at the end of executivo and the optimization that has been done already, and another is ongoing at the moment. And in order not to take too much of your time, let's go straight to the result. So you can see here the way we started, not from a standard, let's say, type of design, because this project is not a standard one. And then you see the gap from where we started 6.6 gigawatt hour of energy demand for the whole complex and 2.3 gigawatt hour generation from the initial configuration of the roof. And then on the green line, you see the constant, step-by-step increase up to, the 4 gigawatt hour as it is now. And then we reduced down from 6.6 gigawatt hour to 5.1 gigawatt hour the energy demand by applying a series of measure reduction. All these numbers are based on a RCP 8.5 scenario, which is something that also we discuss a lot. It's a bit too heavy. We know that we will not be here, and we will not be taking too much care about our anyway. I'm joking, but of course, I mean, we know that probably scenarios like 4.56 are probably what we hope and we would like to, we expect to reach. So in order to say that, of course, we have put a very conservative climate change scenario in our energy modeling. Secondly, the element of the use of these spaces and the performance gap and the ability of the Polytechnic of Milan to influence the behaviors of the people and the users will be key in moving forward to reaching the net zero energy target. And the other element is the further increase of the production from PVs. As I said, we are now looking at increasing it above the buildings, and so it's not yet a finalized process. Last but not least, the point is that all this is looking at the campus as an integrated ecosystem, but still as a kind of standalone, big complex. But, and I'll hand over to Mario, this is part of a larger, ecosystem of campuses and assets and of the Polytechnic of Milan, but also insists into an urban environment of the city of Milan, where energy community solutions can help also, not just to balance energy demand and generation on an annual basis, but actually having a very efficient way of using renewable generation locally and instantly. So I'll hand over to Mario for taking this and taking to the next step, for the renewable energy community of Milan. Thank you.
Thanks, Paolo. I mean, Paolo was showing us, Paolo and Elisabetta were basically showing us the optimization and let's say a multi-objective optimization which takes into account beauty, productivity of the PV system as an overall aim, the carbon footprint reduction have been, let's say, the driving forces of this overall project, which is actually a lively project. And this, let's say, this optimization will continue apart from the project, even during operation. This is pretty clear. I mean, I'm doing as a job, let's say, being the delegate, the energy bills controller of the university. And so I'm ready, I'm aware that there will be something to do, because it's a very complex machine, as Paolo was saying, and it will be a significant effort for sure to make it work properly. Let's say, going back to the discussion I was saying at the beginning, so what sustainability is about for us, and all the aspects that Paolo was highlighting before speaking about the energy community. There is something that we are working on now. You don't know, so I mean, I'm telling it to you now and the crowd. We are trying to make an experiment and organize an assembly of the users of Polytechnic. So we are basically taking a sample of the community people of Polytechnic, which will be mainly students, obviously, because it's 90% of the occupants are students, and we will take them as a sample to build, with their feedback, policies, communication strategies, and ways of managing the complexity that we were discussing. So this is a project that we are starting now, and it's mainly centered now on energy, for the energy system, and the reduction of the emissions. And it's, let's say, partially answering what you were saying about the role of the occupants and the fact that you don't really reach the aim of the carbon neutrality if you don't have people involved. I mean, technology is not, unfortunately, I have to say as an engineer, technology is not the only thing. This project, I was saying, sustainability as a whole for us means something, and this means that we value as well the social part. And this was, let's say, one of the main reasons why we started a couple of years ago a work with the municipality of Milan. And we funded with the municipality of Milan and some other partners. I'm not sure if I have to do, no, I have to go back. I think there is something missing in this slide. Okay, it's moved. I mean, doesn't matter. You don't have to read more. I mean, we funded an energy community with social aims, which means that we built up a community where users can share the electricity produced by renewable energy plants, so mainly photovoltaics actually, in certain areas of the town. And let's say a subsidy law, which is actually in force now in Italy, gives a certain amount of money as a function of the energy, the amount of energy that is shared within the community. So if with my plants at Politecnico in Milano, I produce electricity and I do not have demand enough, I can share it with the community of the people which are around me. And this will produce a certain amount of money given by this subsidy law. And the idea of the Cercami is to use mainly the money which comes from the subsidy to fund social impact projects in the area. And so we have that, let's say, the area of the project La Goccia, where the 5 megawatts of electricity, where 5 megawatts of capacity of photovoltaics, about 5 megawatts of capacity of photovoltaics will be installed. It will be one of the areas where Cercami is working on. And the idea is that our photovoltaic plants and electricity that we produce through Cercami will create a bridge between the project site and the urban tissue which is around, the society, the people, the citizens which are living around the project area. I mean, a bit helping, or let's say going in the same direction that of what Elisabetta was saying earlier. That, I mean, the project it's a place. La Goccia will be a place that hopefully will be lived by people of the area as a public space. On top of that, the idea to use the renewables and photovoltaics, which are integrated in the project, as Paolo and Elisabetta were showing you, as something that creates a further legacy and building up a relationship with the town around is, to us, pretty crucial. And this is the reason why we pushed and funded with the municipality of Milan, Cercami, with this specific aim, and we are already with the plants that are installed in the green area there, which is the configuration where the whole campus, not the Bovise one, but the Leonardo one, is. We are already actively producing energy and distributing it to the community. Let's say what this means that for La Goccia, we have 56 active members, and as you see, 25 kilowatts which are already there of capacity installed. It will be 300 plus 382 in 2026, and will basically reach about 600 kilowatts in 2027. These are a completion of the fact that the integrated photovoltaic in the system does not have only the role to decarbonize our energy system, but has as well a social value given by the project. I'm done.
Okay. Yes, first of all, thank you again. I mean, the richness of these projects is really amazing. I think we started from people, we had a journey through architecture, engineering, sustainability, we come back to people. I think this is really what I appreciate on this experience. And I also would like to come to a few questions. I'm really curious, I guess you also are. Maybe what I propose, I saw that there are a few questions. Maybe I would first of all like to invite on stage another voice, Heinz Ossenbrink. Thank you, Heinz, for joining us. I would like to add also your voice to our talk, since you have served over 2 decades as a program chair of the European PV conference, and you have a special observatory on this matter. We also had, I think you have many questions. Maybe we can take very, very quickly a few. What I really would ask, not having consideration, very direct questions, and maybe also you have realized that we are not going, the goal is not going technical specification, but trying to keep an observatory on the perspective of this project. So please don't ask very, very technical questions if possible. And there is maybe, Vip, there is one question there.
Yeah, thank you. Thanks for that very interesting project. You mentioned something about pollution of the area, pollution of the ground. And I wonder, how did you deal with the pollution, or how will you deal with the pollution? And maybe also, who will pay for it?
Mario can add about the payment. So first of all, there was a great collaboration because we didn't enter in the detail, but there was an old agreement of that area between the Politecnico and the city of Milan. And originally, the expansion area was more entering in the forest. So when we enter in the process, we ask that for us was really important to maintain the new construction more close to existing, again, as I mentioned at the beginning of my presentation, to maintain the forest as much as possible. So we divided the 2 areas with different type of cleaning the site. So where the buildings are built, it's more a typical cleaning area with excavation. And this was, again, depending of the footprint, was falling in the polytechnical property or was the city. So I think the Polytechnical took the charge to organizing, and it's taking the lead of everything happening on the site, even if some area are property of the city of Milan, and they will pay. But the Polytechnic of it, it's a great thing. It's keeping the control and the organization of all of that. And depending on the area, because the pollution was not exactly the same everywhere. So there was a lot of testing. In some area, there was really very low pollution, so excavating was really more easy. In some other specific area was more. And this was for the area where we design where the buildings are going. For the forest, instead, that it's property of the city of Milan, was a partnership between the city of Milan and Museo di Scienze Naturali, a group of people that are specialized in a different type of cleaning, what is called phytoregeneration. So we don't excavate it, because otherwise we destroy everything. And again, they did an incredible map of where the area. Luckily, it was better than we expect. So this work has already started. And in our design of a campus, we design what we call corniche. In reality, it's a pathway that it goes, on the round next to the railway inside the wall, protected, where you can go around the park, and some passage that it will just pedestrian, that it will, and bicycle, they will go through this forest. And so for the first part of the campus, that it will be ready, we hope, beginning of 2027. People will be able to walk. There will some area that will be protected, say some cleaning are going here. So, but people will be able to walk through. So this was the two different type of process that we went through.
I don't think I have to add more. The only thing perhaps I can say is that I'm very grateful to the technical part of my administration, which I can say with a bit of proud that is not acting as any other public administration, let's say. They are very active, and thanks to their approach, we did manage to, by now, to carry out such a project. Let's say the renovation or the restoration of the pollution in that area, it's not an issue only of the area of project that we are discussing today. It's the overall area which is very polluted, because I mean there was in that area there were in the last 150 years extremely polluting industries. Everything has been produced in there, and even for the buildings that we built from the 90s, mid-90s on, the restorations and the new buildings, it has always been a nightmare. Very difficult to keep on track with the roadmaps, because I mean, as soon as you were starting to dig, it was always very, let's say, tough pollution. And actually, the north part of the campus, it's in a better situation than the one that we are living today. So. It is always a cost that is somehow considered.
Thank you, Mario and Elisabetta. Yeah, this is a project, I guess, just one topic, just keeping one topic, we could talk for hours. So, but I would like to try to touch upon a close perspective on the solar and maybe if possible we can take later on, because I would like in the meantime to add the voice of Heinz on the conversation. So since Heinz, you served for a long time as a R&D of PV at the Commission, you have a special observation on this topic. I want to be very direct. In your opinion, could this architectural and urban dimension of photovoltaics be an added value and also become a form of excellence for Europe?
Thank you, Pierre Luigi, for this nice introduction. That's a very provocative question, simply because to describe it, you would need to know all the history of building integration of photovoltaics since, I think, the first solar architecture conference I joined in 1985. But when my relation to what is the appearance of photovoltaics in our surrounding world was initially majorly influenced by the beauty of physics of photovoltaic conversion. I would say an elementary particle goes into another one without consuming any material. And but then I learned very early on that more than efficiency improvements by device physics or material science, it will be what are the people doing with this and what are the conditions of it. So coined in the phrase, I would say, people need to want it. And how do you get there? So the idea of making clean electricity, initially at forbiddingly high cost, how do you get it there? How do you make people wanting to have it? And there I got mostly inspired by what was then evolving and initially as a driver, aesthetics, a word which a physicist has its difficulties a little bit. So I would rather always call it the beauty. And try to transpire this in events like PV Forms Landscapes, which at the end had, I think, at this last of its 9 editions, this success at the Biennale di Architettura Venezia, I think 2022, you were there, to understand a little bit what does it need. And it's not only of buying cheap modules in China. It's something much beyond, which goes much more in the philosophy of what is around us. And in this context, I want to compliment really the Politecnico di Milano for this project, which is such a symbol for the energy transition. You go on a place which was once gas and storage and conversion polluting, and you make something else. You make an energy which is visible for each and everybody going into this campus. It's becoming an energy source of the people. And I have witnessed many openings of PV plants where children were playing around, and they made a big party out of that. And it's not like opening a nuclear power plant. It's just such a difference in society. And so I learned the future of photovoltaics depends a lot or almost entirely how to integrate it into the society. So it's not, surely it goes past how to integrate it in a building, or looking in a building like this is a complete energy system in terms of consumption and production, which is almost new. I think the last time a building was conceived like this were the Romans, the Roman architecture. But later it was lost because energy was so cheap, you wouldn't care about the consumption and it wouldn't care where it's coming from. But today it becomes this idea that it's a complete system and it has to integrate also in such an energy system. It has to integrate in our life. It has to know when we want to charge my electric car with that and so on. So this is all this part of integration. There's another part of integration, which is the integration into future generations. What we build now, we now last 50 years at least, if not longer. So we built it for those generations for which we paid already the electricity bill now. But they have to live with this. They have to live in 50 years and say, oh, how ugly, what did our parents do with this? So we want to give them something. We wanted something remains for the future generation and saying, this is a new way to go. And there I see this future of what we are talking about here.
Thank you, Heinz. I fully agree on the topic you mentioned at the beginning. PV is something more, and this more can be elaborated in different ways. Today we have seen an incredible example of it. Mario also highlighted what I could call the civic dimension of energy of photovoltaics. You talked of a project which was a factory and still remain a factory of ideas, of energy as well. So this is, I think, an amazing demonstration of how architecture can be a kind of a gift to the society in these terms of creating communities. You highlighted also all the effort of Politecnico in this sense. I would like maybe to come back a little bit quickly on the project dimension, the architectural dimension of solar or photovoltaics, and ask Elisabetta that you mentioned before that light is one of the key materials you are using in his immaterial dimension, but maybe with photovoltaics we can elaborate also light in his materiality dimension, is in a different way of being an active component. And in Renzo Piano Building Workshop, of course, this is not the first project, but you have a tradition of considering photovoltaic as a true construction material in your projects. I would like to ask if and how using photovoltaics in your architectural concept is changing the way you are approaching the design. Is that something new you see in this kind of magic material producing energy for the first time?
Yes, I think you're right. There is a history of different type of project in our office where we use photovoltaic. I think first we started on opaque roof, in some cases like in Athens, for example. And it goes back, honestly, to like probably the first really project that it was really part of the architecture was the California Academy of Science in San Francisco. So we go back 27 years ago. So the real first one. But I think the transformation, I think it was what I just mentioned about when we move from an opaque wall to try to understand the integration with glass, just to make the people aware, what he was just mentioning, when you expose them in your project, people, are more curious, they understand, they can, we do the same process often with how when we design structure of the building. We like exposed and try to make the people how the building is working, how the building is standing up. And Renzo like to use the word that the structure is a muscle, of a building, and it's better to show for our point of view, the architecture is not just a form, you just not to create a special building, but you need to come out, first of all, you have a desire, a dream of a client, and you need to try to give them, and transform the dream in a space. And so the transformation of the photovoltaic, I cannot tell you how many, tests that we did about the distance between the cell. My colleague cannot take anymore, but, between 12 millimeters, between 12 and 18 and 22, and make the difference on the reflection, on the facade, on the nature, on the thing. So it's a continuing process.
Yeah, sure. Thanks, Elisabetta. I think this, I agree. I guess the crucial point, the detail is a kind of connection between the architectural concept, the performance is the point of compromise, some way of performance also. In fact, I would like also maybe to involve Paolo on a quick reflection on it, maybe on how the architectural detail become itself a kind of generative element and point of compromise for the project's sustainability performance. How did you also relate between the architectural concept and the sustainability aspect through the detail, let's say, of the project?
Yeah, maybe I start from the fact that the detail, detail is very much related to what Elisabetta said now. But if we make a step back, we look from the very beginning. I think what we are trying to show here is the integration of the process. So the thing is that by even which is part of the of the whole conversation here. I think the concept of total design, and from Arups, in key speech, and the long-term relationship between Renzo and Ove and others, of course, in those years, it was and it still is the challenge that we are facing in a world that is even much more complicated than in the past. So sustainability is not just a vocabulary of words, of concepts. It's actually a language, and it's a very complex language. And so it requires grammar, syntax, and everything. And so the point is that nobody can speak the language of sustainability alone. So sustainability comes out from this integrated process. And so when you look at the details is somehow there, even if it's not fully, focused at the beginning, but it has to be there. So it's part of a larger picture that has to start with clear ideas. And I wanted to stress what I said before. In our world, in our transition, in everything we do, where complexity increases, and as we discussed today, it's not just a matter of a building or a complex or a building, it's a matter of these complex buildings into an urban environment and how everything is really connected. The point is that if we don't fix targets, and if we don't all together work against those targets, we're not going to reach the target. So it's as simple as that. And this goes back not by, again, quoting again Arup. When he said total design, at the end of the day, is just having an empowered group of people that are all working together to fix priorities. That's it. And with excellence. And the point is, I like the second part of this sentence of the speech, actually, more than the first, which is defining total design or total architecture, which is that in reality, this doesn't happen. It's almost impossible to reach the target, but we have to keep trying to do that. So it's not just say, okay, it's easy. It's very difficult, but it's really because it's difficult. There's an extreme value there. And so then details come into, because behind details, there's the excellence, there's the need of having very robust solution that in another form is nowadays, as we are used to say, we have to have science-based, database results, because otherwise it's just, telling stuff. So you have to prove that this is actually happening in reality. And so technical excellence has to be there.
Yeah, sure. Thanks, Paolo, for remarking this leadership of integrated design in a way, and also the relation of sustainability with other scales of governance, which are not just technicalities or technical performance. I think this is also the message. And unfortunately, time is running, because I guess all of us, including me, would have hundreds of questions, but maybe we can take the chance also to catch up later, and we have to conclude this session. Of course, I'm not pretending to conclude in any way, because I guess I'm convinced what we heard today is not an ending, but for all of us is a starting point about the reminder that architecture, if we want to call it so, architecture is above all a way of thinking, as we titled this session. So just to conclude, I think what emerged is a kind of shared message, very clear from the project, that when architecture, engineering, sustainability and communities are together, solar is not just a technical add-on, but it's really a cultural part of the projects, capable of guiding new form of design of urban environment and of of our cities. So I just want to thank again our speakers for joining us today. And I also want to wish you all a nice rest of the conference, and if I may, also a very bright and very solar design journey ahead. So thank you, everyone.
Okay, good morning. We start the next session, which is about new development. And I will start with a brief introduction. I'm part of the ETA Solar Florence, and I was in the University of Florence and member of the staff, research staff of Habitat Research Center. This short presentation is about the role that ETA Florence has been done in the last more than 30 years, since the early beginning. We was just remembering with Angela Grassi, I was starting research with the European Commission in this field, but especially in PV for the integration expertise, the technical consulting and project development, applied research and innovation, all the role where the ETA Florence have been leading since more time, lot of time, and especially trusted energy and sustainability partner to be proposed themselves as a possible partner to university research center to develop research, renewable and climate innovation, but also EU policy, international cooperation, science communication, a reliable partner for the future project and development that you may be conceived to develop. And especially for the perspective on the BIPV, I could really add really few things after the beautiful presentation we had this morning before me, because the value of the integration of PV is in the architecture, is the architecture itself. This is just a vision of a project that has been approved by municipality of Florence to build a new building for the bigger company in the heart of Florence, a renovation of an existing building with a roof with a transparent photovoltaic integrated into luminaire of the roof that's covering interior wall. All this project has been the participation of ETA as a consulting company. The agrivoltaic also is a very promising future. It's also a field in which ETA had a leading role, and very promising for Italian agriculture, for Tuscany especially, but also in the field of social housing, like this project that we have developed in the past from University of Florence and Habitat Research Center and ETA Florence Technologies. It developed through all the many towns of Tuscany, like Leghorn, like Piombino, and others, to demonstrate how the normal building could find a new solution, a new iconic elements to find their identity into the urban tissue. And this is one of the best solutions we applied here in Florence. Is a pediatric hospital, children's hospital in the hills surrounding Florence. And in the value of having a photovoltaic here is just a demonstration value. The symbolic value of it is the heart of this hospital, where people entry have the first approach with this prestigious institution and can see how many different integration can have the photovoltaic for moderating the solar light, produce, of course, energy, and to demonstrate its feasibility to everybody. But also in another iconic building, a demonstration building, we realized near Lucca, where several technologies have been applied no time to explain this, but is an incubator. And interesting because this building has been funded by local commerce chamber here in the commerce chamber of Florence. Here is commerce chamber of Lucca that funded this building. And also because we applied in a facade, not only just applying the photovoltaic, but designing a new modular prefabricated facade components with the concept that can be modulate the solar performance, modulate the solar light, modulate the transparencies, even the ventilation inside through different layers sliding in front of one of the other, but the exterior layer was photovoltaic. It's one of the most successful projects that have been developed together with the Habitat Research Center and ETA Renewable Energy Florence. So for this, we go quickly to the session of today by just mentioning other offering of ETA about the collaboration in different topics. This one other project developed in Monte Carlo, the Monaco Yacht Club, to how different can be from social housing to prestigious yacht club in Monaco, but the message is always it remains the same. And there are some important researchers, European researchers, led by ETA, Symbiosis, Seamless, which presently are celebrating a meeting, and Resilex and others. So I go directly to let's work together. Of course, this is the message that I transmit to all the audience. I go directly to the first speaker of our session, which is Alvaro de Gutierrez of EURAC Research Italy, about curtain wall facade design integrated with PERC and shingled harpic technologies. Please.
Well, thank you, Marco Sala. It's a pleasure to be here with you, and I think it's a great message to see how can we work together. And today's message I want to give as we start is, sorry, I will go back to the presentation. I want to give a presentation of how we work together with two of the groups at EURAC Research. So that's the Photovoltaic Energy Systems Group. Within that group, I'm working as a researcher in the group of integrated photovoltaics led by Laura Maturi, and we collaborated with the Energy Efficient Buildings Group to see how can we design curtain walls with a building perspective. If I go to the next slide, let's see. There we go. So I will share two of the projects. So that's Fourier with partners such as Foki, and then also from MC 2.0, which is a project that's running 3 years and ending this February. So for the presentation of today, I'll just introduce building integrated photovoltaics, passivated emitter rear cells, and also heterojunction shingle cells. Then we'll go into some curtain wall designs developed in the MC 2.0 project. And from there, we'll go from reliability a bit more into performance in a controlled environment. And finally, we'll share some design findings for future curtain wall development with BIPV. So just a reminder, it's a holistic process we look at. So indeed, it was mentioned already today. We look at technology, so new developments, but also energy matching. And also we have to focus also on aesthetics so that actually the people want this technology to be applied. So where are we standing? I think it was already mentioned, but also within the renewable energy sector, you know already, solar is growing the most. And you can see that distributed PV and utility, it's predicted to grow to above 2.5 terawatts towards 2030. And we have to note that 30% is in the distributed sector. And then we have to highlight that BIPV is a niche sector that we have to encourage, I think, other stakeholders, especially in the building industry, to go from that 3% higher and take advantage of this amount that is predicted that can be reached through distributed PV. So I bring you today two insulating glazing units. One is from Glass to Power. It's an example of a single glazing system. And then here you also have from MedSolar some example of a triple system. What was interesting in the project in Fourier is actually how this technology is developed. So you also have to consider it's not PV exposed to air, but also to other materials such as argon. And what you can see is that there's different intralayers. And you can see they're highlighted the PV in the white section, but we also tested integrated color glass. So that's gray in this case. The technologies of interest, we chose to continue investigating PERC. It was the dominant until, let's say, 2023 or so. Now it's taken over by more advanced like TOPCon. But we still think it's a reliable technology that can be tested and implemented. And then we also were interested in heterojunction cells as they're quite stable but can deliver high performance. And yeah, how does the shingling work actually? So we took the heterojunction systems also together with AMAT, Applied Materials. And with them, we took M2 cells and lasered them to cut them into strip into the size of the facade. And then through electrically conductive adhesives, we could get this overlap of this flat, long system. You might be wondering why. The advantage that we saw here is that, okay, for BIPV, you always get complex designs and can be an advantage to size your module according to your preference, not just to the M2 cell or other types of cells, but you can actually also increase then the area efficiency where you're installing active components. So first, we'll go through the reliability of curtain wall designs. And here there's a partner called Glass to Power, also present today with a poster. And here we looked at the semi-fabricate level where we tested, I think, over 40 types on the market and also from the project. And we combine it with the insulated glazing unit. And here are some of the results. So actually, when you do thermal cycling, depending on the chambers, these systems can go up to 2.5 meters. So we had, let's say, mini modules of these systems. And these I bring you today are two of the end product tests that we did in two samples. And you can see that the electroluminescence, so as to see the, how the state of the cells is. And you could see actually there was also damage in one of these samples, but over the 1,000 hours of damp heat test, in this case, there was no further degradation affecting highly. What we saw here is, of course, there was degradation, but not going below the threshold of 95%. If we go forward and we take this data, we further stress these modules. I think it's important to highlight in this industry that is quite new, is to maximize all the tests that you can do to find what are the issues. And we also have performed thermal cycling, and we're at the moment performing the last set of humidity freeze, but so far the threshold of 95% was not surpassed. When we look at the power output and also the fill factor, what's interesting is that within the IGU, we could see the IGU could act as a protective layer, but it was hard to see. And then we had one sample. So we tested PV inside the IGU and PV outside of the IGU to see the difference. And we saw already if you have a cell with, of course, a low fill factor, it's likely to have more issues after the thermal cycling. If I go to the next, here I can just quickly summarize the findings. So if you compare an IGU that had the same samples with a PV that was not in the IGU during the same test, we had slightly more degradation. So you could see, okay, the IGU protects the sample, but not to a high extent. So it's interesting to see this similarity also in the fill factor, but it does not affect negatively the performance. If we go forward, we scaled this up to a mock-up, and then we've also tested how to install these systems. They reach up to 130 kilograms, so it's also quite challenging to install. And here you can see a bit of the process, and then there we're also monitoring what is the performance. And you can also do DPL, so daylight photoluminescence, to assess what is the damage maybe during installation. Secondly, so we saw reliability, and now what is the actual performance? You saw that mock-up is not fully in a controlled environment. Here we looked at a different type of facade in a controlled environment. So we took a design in the research laboratory that we have at EURAC Research, and we implemented this unit that you can see here. So we had 4 let's say, facade units, 2 with insulated glazing units, and 2 with spandrel, so that means opaque. In half of them, we had PERC cells in the top part, so there's still visibility from the indoor for comfort and the living space. And also we had these full opaque systems. Here you can see quickly the installation and some of the sensors we installed, I think over 40 PT100s, and then also we measured the heat fluxes inside the chamber. And then as a summary of what the findings were, actually for PERC cells, we saw 92% performance ratio, and then for heterojunction, 88. You see more challenges with heterojunction with higher voltages, and also when there is a shading pattern, so you have to assess that by designing correctly your parallel strings and so on. And then I think one of the interesting findings here that I wanted to bring to highlight is how we had integrated sensors within the lamination, as well on the back side and front side. And some of these findings were quite interesting. So actually the gradient between the insulating glazing unit in the front and the middle section, it was around 7 to 8 degrees. And then the back section that is in contact with the house at 25 degrees constantly had a 5% gradient. Also, what was interesting is if you look then at the transparent IGUs that had, let's say, the cells on the top level, and you look at the temperature, from the difference in temperature is 15 degrees. This was carried out in the month of November, so quite cold, extreme outdoor temperatures. But I think it's a good point to the industry to just highlight, to continue measuring this, because in the summer periods you can see extreme changes within one glazing unit, and that can cause some challenges. So it's important to design with this in mind. And what we can conclude as well with this is that we had a G value of 0.68. And yeah, overall it was quite interesting to see the behavior and continue to monitor the systems. So yeah, as conclusions, I think the main points are that we can have this high retained power after thermal cycling, compared to not having the IGU. And then we also saw 3 points. So what we were talking about, aesthetics, we also have technology and energy. So we can incorporate color also to cladding facades and this kind of systems. We can also use this technology inside IGUs or spandrels, and that the performance ratios remain relatively high. And an additional observation is this temperature gradient that you should be careful, as we've registered inside as well, of course, up to 65 degrees in the month of November, the temperature of the cell itself. So I expect in summer we will reach higher values and a higher difference within the glazing unit. Thank you.
Thank you, Alvaro. I was just wondering. Thank you, Alvaro, for the interesting presentation and all these components, and also for being perfectly in time with the presentation. So I would
Alvaro,
like to
I was
introduce
just
my
wondering.
co-chairman, which is Sergio Mattalucci of PV Magazine from Italy.
Thank you. Alvaro, I was just wondering, so your private research center is in South Tyrol, and are your conclusions based on geography, or do you think that they could change as a function of different geographies, like if the test was made elsewhere, for instance?
I think it's, yeah, thank you for the question. It's a good question. We test more in the alpine environment, so you do get extreme temperatures in winter, so colder, but also in summer. I think that is important to test on all these environments. So yeah, I would recommend that. But of course, when we present things like the performance ratio, that's already normalized with temperatures and also with irradiance, so you can compare throughout all the systems. So that was done as well.
So thank you so much, Alvaro de Kreuter. And I will ask the next speaker to take the floor, Lenneke Schlauff from TNO Solar Energy. She will speak about cassette PV. It's interesting that we have the second Dutch speaker today. As we know, the Netherlands and Italy are the two countries with the highest number of patents in the BIPV sector. So it's a good representation of this. Please, Lenneke. Thank you.
Thank you very much. Yeah, I will not speak in Dutch, but I will speak in English today.
because my Italian is also not that good. Welcome and thank you for inviting me to give this presentation on our cassette PV project. With this concept, we would like to try to accelerate the BIPV installations in Europe, but maybe also outside, because this technology is a simple and easy installation method. We do this work together, so I'm from TNO, but we work together with Chameleon Solar and Sorba, also Dutch organizations or Dutch companies, and it's part of the MC 2.0 initiative. Like I mentioned, facades like this cassette facade is a very nice, easy installation. It's, at least in the Netherlands, a very common way of installing facades. So the building and construction sector is used to this concept. And in order to accelerate the installation of BIPV, we thought it would be nice if we could combine the two, because then the facade constructors already know how to handle and how to install these panels. So we try to combine the PV with the cassette concept, and with that we hope to reduce the installation costs, installation time, because it's easier to install, and also material usage. The first concept we tested consisted of the following bill of materials. We used an ETFE front sheet, then as an encapsulant POE, a clear film with print, because we do not want to have only the black or dark blue colors, but we want to have an aesthetic appearance as well. Then again, an encapsulant POE, solar cells, another encapsulant, and we have a fire-resistant aluminum composite at the rear, also in order to apply to all the fire safety regulations. And on the right side, you see an example of, say, a cassette PV wall as we have built it. We tested, of course, how this worked. We saw already that it visually can look very nice. However, what we observed is that after lamination, so we do a flat lamination, and then we set the sides of the laminate into the cassette shape. And we looked at electroluminescence imaging before and after bending to see if the PV cells survived the bending. And 5 out of 12 did show some cracks, for example, but also higher resistance in interconnection due to the setting and due to bending. And also one of the cracks, there was already a crack before setting, and that grew. So we do see some effects of the bending of the panels. However, if you look at the performance, then it does not show a very large effect. So we saw that all the cell parameters after bending still were within 2.5% of the initial cell performance. So we do see some losses, but they are not as large as we would have expected. We also performed damp heat and thermal cycling according to the IEC 61215, and on the right you see the results of those. And as you can see that after one IEC testing for both the thermal cycling and the damp heat, we still are within the 5% degradation that is still allowed according to the test. And we do not see any visual changes after these testing. So they're looking good. We do see some effects of the setting in cell breakage, but we also saw in some cases that the core of the sandwich, of the aluminum sandwich, was broken after bending. So there was still room for improvement. So the next thing was to try to improve this. And also we wanted to use more sustainable materials, because the ETFE front sheet contains fluorine, and we wanted to see if we could could use a material without the fluorine in there. So we used PET as an alternative. We also tried to use several other encapsulants, because of fire safety issues. And then, of course, we need to tune all the processing conditions again. So then the final module stack looks like PET, an encapsulant, again the clear film, encapsulant, etc. So only the front sheet was changed, and we tested some other encapsulants. And on the right, you see then a sample after lamination. And in order to get the shape for the bending, we do laser trimming of the edges after lamination, and then we set the sides to form the cassette shape. Again, we obtained very nicely looking samples after lamination, so no delamination, no bubbles in there. However, we did see lamination after bending and also after creep testing, and you see a few examples on the right, and especially the bottom right, you see clear delamination occurring, unfortunately. We also tried primers in the module to see if that could promote the adhesion, but so far, unfortunately, without any luck. We also tried bending at elevated temperatures in order to soften the material a bit more, reducing the stresses after bending. But again, no luck, unfortunately. So we tried quite a few things, but yeah, I have to say I cannot tell a good ending here, unfortunately. We're still looking for the right concept here. It does show, again, good performance electrically before and after bending, so we do not see any impact on the bending, but yeah, the delamination is of course a problem. One of the things that we noticed is that the PET front sheet that we use is quite thick and gives quite high reducible stresses after bending. So we want to see if replacing this one with a thinner PET film can do the trick, or use a sandwich of PET and ETFE. Then of course still you have the ETFE in there with fluorine, but the concentration will at least be reduced. And despite the fact that POE might be a bit more tricky when it comes to fire resistance, it might be the only one that does the trick with, having enough bonding strength in this bill of materials. So that's also one that we still would like to test in this structure. Once we have the correct bill of materials, we do want to do some fire testing to see the fire safety. And also the color stability needs to be tested because the thin PET or the ETFE film might affect the color stability of the print. So we want to do Q-track testing in Arizona. Arizona sunlight is a bit better than in Europe, and it's also concentrated, so we can do the trick in half a year, what normally needs 10 years, at least in the Netherlands. So that's what we plan to do next. Yeah, so not a happy ending, unfortunately, but still enough to go forward in the project. And with that, I want to acknowledge my team. So Ozan Apperdin and Lars Okel from TNO, Niels Schuring from Sorba, and Chirag Raja Reddy from Chameleon Solar. And I would like to acknowledge the MC 2.0 for financial support, as well as the Netherlands Enterprise Agency. And thank you for your attention.
Lenneke, may I ask you just a quick question?
Sure.
Do you know more or less the timeline for the project, like the next steps?
Yeah, we're currently working hard on, say, replacing the front sheet and testing the POE again. So I hope that to be finished in the next quarter. And yeah, then especially the Arizona testing needs half a year. So so at the end of next year we would know more if this is a successful approach or not. Yeah.
Okay, thank you, Lenneke. And I call the next speaker, which is Markus Beichmann from Invitac company from Germany. Please.
Yeah. The audience, welcome here to Florence. I hope for most of you second time. I want to introduce No, the wrong one, as usual. I want to introduce today a company, Untitled, and a new product that we will bring to the market. Untitled is part of iSolar, which is a German company, very long on the market already. We all know PV years, they count like 10 times. So the company is from 2003, so it's roughly 100 years old. And Untitled is within that company, the specialized and focused BIPV group. The advantage is if you have a big company focusing on standard modules with a gigawatt manufacturing in China, Turkey, you learn a lot. You have access to the newest technologies, manufacturing technologies and materials, and the BIPV group can really then focus on the architectural part. These are just 3 selected examples of projects. They are from a worldwide setup. Maybe one of the most complex and most prominent one is the fish market in Sydney, where you can see here the white pyramids. These are all the pyramids. They are all manufactured from colored PV modules. This is a very extreme design, obviously, for a roof installation. It's around 250 kilowatt. But also there are standard designs like in Zurich, for example, for colored facade. Or you can see here also at the headquarter, manufacturing headquarter, these stone colored. This is a more standard thing. The issue that we are still facing in BIPV is that we all know the left curve, right? PV became very cheap in the last, for example, 10 years. It dropped 90% in the price. We know the curve and we fear the curve, actually. But on the other hand, in BIPV, we cannot just simply follow that curve, right? Because when we look at the right side, this is the cost increase of the working cost. This is just from the German market, but in Europe, it will more or less be the same for other countries. So on the one hand, material costs came down, but our costs, they move up. And not just the cost per hour, also the hours we have to spend for projects, because the norms and standards, we all know that they're all increased, right? So that means the BIPV overall cost limit is not following that so fast. And that also means for a module supplier or a product supplier in the BIPV market, you cannot just follow and focus on material cost and module cost, because if you do that, you are just touching a small part of the overall adaptation. If you really want to work on the system cost for the customers, you have to also make it possible that other factors are reduced from the application phase. If you look at that picture here, we said, okay, for the next year, we are focusing mainly on shading with our product, because each product, each building has shadings. It's from the horizon. You can see that from the left. It's from neighbor buildings. It's from a tree. In the morning, Pierluigi showed us that nice architectural composition of a tree putting shades on a facade. This is more the technical part. Then we have roof elements, right? We have a lot of shadings, complex shading situations. And if you bring in a project the shading analysis with simulation, BIM models, this is a lot of additional cost in the project. Maybe first we have a short look on the aspect of shading from a technical part. And as I assume, we have here a mixed audience. Some people are from the PV industry. They work their whole life on these topics. So I'm sorry, I'm just touching that on the surface now. But maybe a short idea what happens when there is shading on a solar module, right? If you see that here in a standard PV string, if there is a shadow on a part of a cell, the current drops dramatically for this whole serial composition. And the other problem is the other cells, they don't know about that shadow and more or less try to push the same current through that covered part, which leads to a lot of stress on the module level. The protection of the module kicks in. Then we have parts and problems with hotspots. And of course, we have an immediate power loss. This is easier to understand, but on the long run, this module has heating effects and it will destroy foils. It will destroy also the solar cells. And on the long term, it will reduce the lifetime of that module. You all probably heard about that because since beginning of this year, there's a lot of marketing about that from some big companies for the back contact solar cells. They are introduced in standard PV modules already. They are now on the market. And the big advantage of these cells is that the whole electrical contacting layer is moved to the backside of the solar cell. Right? Normally you have plus-minus poles on each side of the cell. This is also why we have the silver wires on the front side of the solar cells. But in back contacting, we move everything to the backside. So the first advantage, this is easy to understand, is when we don't have any covering on the front side, we can absorb more light. So the efficiency goes up. But also because of these cell designs, these solar cells have a better behavior for temperature and reduction of local heating. This has to do with that cell design. But the most important point for us in BIPV is that when these modules are shaded, they still produce more energy. And the trick, and this is now really very much on the surface because probably the details they're taking several weeks to explain, because of these contact points we have on the backside, we have, electrically speaking, between these two neighbored elements always a diode which acts basically like a valve, right? And normally when the current wants to flow through an uncovered module, it can just follow that green path. And if there is a partial shading on these solar cells, these valves open a path for the current. And that allows us that even when there is a partial shading on these cells and the modules, that the current can still flow through the module, which is obviously a big advantage, especially in smaller BIPV installations where there is no budget, no time for complex shading analysis. It will reduce the coupling between the building and our solar modules because these solar modules are more resilient against shading. The other topic, and that is more from the technical side, more robustness against shading, more energy per square meter and more power per square meter because of the possibility that a full surface can capture the light. We also reduce the hotspot risks, but also because of that reduction and removal of complex shading analysis from projects, especially for existing buildings, gives us a lot of technical advantages. But there is also one other very nice effect. It is black. It's a unique surface, and we don't see any metal wires on the front side. And you all know that from many companies, you can get solar modules with front colors, front printing, front foil, whatever. But every time when the sun really shines on these modules, you will still see the metal elements, the wires, the connection elements as silver lines, right? But if there are no silver lines, the color will be completely perfect. It will not be possible to visit, to see any silver lines, any wires. So it is just a perfect possibility to integrate such modules into standard buildings where the people don't see any electrical elements. It looks like just a standard facade element, and this is fully compatible with existing building materials. So that is what we want to contribute to the application cycle of BIPV to make BIPV more resilient and easier to plan. And our target is to support by this the adaptation rate in building projects. Thank you very much.
Marcus, a quick question. What's the reaction from the public and from possible clients? Do they like back contact, and eventually, which sort of difficulties do they see in adopting them?
According to my experience, a lot of people already tried with the standard back contact modules to put them into buildings, but they have then always the problem with the building code adaptation, right? It's the wrong class thickness and so on. So a lot of people, they are quite happy that back contacting technology is now also moving into BIPV, different sizes, colors, class thickness. Yeah.
Perfect, thank you. So we can move on with the next speech, if it is okay with you. So Nicolò Zennaro from University IUAV, Italy, will speak about BIPV for Tegola Canadese roofing. Please, Nicolò, thank you.
Thank you. Good morning. My name is Nicolò Zennaro from Università IUAV di Venezia in collaboration with Tegola Canadese. Tegola Canadese is an Italian company specialized in the production and commercialization of bituminous and photovoltaic shingles, with a strong focus on innovation and quality. Today, I present a building integrated photovoltaic specifically designed for metal asphalt shingles. It's a fully adhered BIPV solution developed to overcome current technological and market limitations. Okay. Buildings remain one of the largest contributors to global emissions, both in energy demand and carbon dioxide emissions. To align with the IEA net zero scenario and European policies, the sector must accelerate decarbonization. This urgency increases the need for on-site renewable energy generation, particularly through photovoltaic systems integrated into building envelopes. Buildings represent a huge opportunity for local energy generation due to roof surface availability and daily solar exposures. Integrated renewable technology, such as BIPV, provide a way to generate energy locally while minimizing additional land use. Within this framework, building integrated photovoltaics are promoted by European policies as a key strategy for decarbonization. Roofs represent the primary application area for BIPV, accounting for approximately 80% of installations, with metal roofs offering particularly high potential. However, our internal market analysis shows that 79% still require ventilated substructures. This condition compromises the distinctive benefits of fully adhered roof systems, valued for simplicity, low weight, and structural efficiency. Overcoming this limitation is crucial for wider adoption, especially in retrofit projects, of buildings with limited load-bearing capacity. This limitation reveals a clear technological and scientific gap. Fully adhered metal roofs are rarely addressed in literature, and most existing BIPV still rely on ventilated substructures. Our research responds to this gap by developing a new fully adhered BIPV system for metal roofing. This solution integrates flexible photovoltaic modules into Tegola Canadese metal asphalt shingles, overcoming the constraints found in current products. So our specific objectives were three. First, achieve full adhesion installation without dedicated substructures. Second, ensure simple, fast installation and easy maintenance. Third, ensure high quality aesthetic result, so the photovoltaic elements integrate coherently with the building envelope. To understand our solution, it's essential to know the base system we are working with. Tegola Canadese's roofing system is characterized by a lightweight metal asphalt shingles, installed directly in full adhesion, without ventilation layers or mechanical substructures. The system provides waterproofing and strong resistance to extreme weather. The system is installed directly on the roof structure, typically on a OSB supporting panel. On top of this, a self-adhesive waterproofing membrane is applied, followed by the metal asphalt shingles. These shingles combine a durable bituminous base with a high weather-resistant pre-coated aluminum surface. Attachment is completed through a combination of interlocking geometry, adhesive bonding across the layers, and nailing or heat welding to the membrane. This existing system provided the foundation for our BIPV. Our challenge was to add photovoltaic functionality without compromising any of these characteristics. The development followed a three-phase methodology. The first phase consisted of analysis, reviewing existing BIPV metal roofing systems to identify technical barriers and integration limitations related to adhesion, wiring management, and maintainability. The second phase focused on design. In this stage, we developed a system configuration that meets the three objectives and compatible with existing roofing technology. Finally, the third phase involved prototyping and physical installation tests on a roof section. The resulting system integrates custom flexible CIGS thin film photovoltaic modules directly onto the surface of the metal asphalt shingles. This technology was selected for its flexibility, reduced weight, and suitability for curved and uneven substrates. The custom modules have an extremely low profile and are equipped with a high-strength adhesive backsheet that bonds directly to the shingle. These modules are applied to the Ultimetal HD slate shingles. The combination of flexible thin film technology and existing robust shingle structures creates a unified photovoltaic roofing element that maintains the original system mechanical strength and waterproofing performance. During development, the main challenge concerned electrical connection and wiring accessibility, while preserving the aesthetic quality of the roof. To address this, two coordinated shielding components were designed using the same materials and finish as the shingles. Arch vertical caps cover the junction boxes and the inter-module connectors. A second element, the ridge cap, hides and organizes the horizontal cabling and connects the vertical components. The curved geometry was selected because it offers a softer and less visually intrusive appearance compared to square profiles. Together, this part enables a clean architectural integration with maintaining complete accessibility. Testing confirmed both the feasibility and the architectural quality of the solution. The curved protective elements transform what is typically a technical necessity into a coherent design feature aligned with the roof's materials identity. The final system achieves several competitive advantages. It requires no substructure, reduces total weight, and is fully compatible with existing Tegola Canadese installation systems. It also enables faster installation compared to the most metal roof BIPV, while ensuring accessibility for maintenance. To conclude, this research demonstrates that a fully adhered BIPV can be developed without ventilated substructures. The solution maintains durability, performance, and architectural coherence. The system preserves the visual identity of the metal roof while integrating photovoltaic functionality in a seamless and reversible manner. Beyond technical validation, this work reframes BIPV as a design integrated system, rather than an added technology. It shows how energy generation can coexist with architectural identity, shifting the role of photovoltaics from constraints to opportunity. Next steps include life cycle assessment, cost optimization, certification, and preparation for industrial deployment. This work contributes to advancing BIPV adoption and supports European decarbonization goals. Thank you for your attention.
Thank you, Niccolò. If there are any questions, I move to the last speaker of this session, which is Stefan De Wallet from Soltec, Belgium, who will present the experience of Soltec.
Hello, I'm the last one before lunch, so I'll try not to keep it too long. That's the wrong side. And I have to look for the right. This one, that one. Okay. So that's our building. So we are combining the activities of Soltec and ISOL, previous company. And we shifted from producing solar panels to producing building elements. It's a totally different approach of view. Right, it's a totally different approach. We used to make engines, machines producing energy, and now we produce building elements that have as first functionality the building element, envelope, water tightness, whatever, and additional functionality is producing energy. And I looked at it, okay, let's now take a look at it for the last 35 years. What did we achieve? And I will look at it as if I look at it from as it had been a research project. So step by step, work package by work package, looking at what do we do? What did we do? What do we still have to do? What's the status now? And so we go for work package 1, base technologies, validation certifications, production facilities, demonstrators, market growth. You all know how these work packages work. You have the different work packages, you will go through that. Let's take a look at it. If we did it for 35 years, what did we achieve? What is still the status we have to go? Work package 1, base technology, I have to say, we are quite well. Solar cell technologies are available. Let's say when I started 95, solar cell technology was a bit dodgy, low efficiencies, very high prices. But nowadays I could say we match it. Like one of the previous said, what's still ongoing is this back contact cell aesthetics, availability, dependency. If you go to back contact cells, you depend on a few manufacturers leaving it. So for BIPV, let's say the cell technology is not perfect yet. We still have to manage some things to have it widely available at reasonable cost and being very nice aesthetics. Second deliverable, interconnection encapsulation processes. I think we have that. We all can laminate modules. Lifetime is fine, no problem. All the electrical components are available. Inverters are available. You can connect cabling. You have connectors. Some small things still have to be done, but mostly it's going well. Some ongoing things are adapted electronics for BIPV. We've seen all these shading problems and things like that. There's still some work to do there. Let's take a look at that. That still needs to be done. And then if you go to deliverable 1.3, colors, shapes, things like that, I think we have achieved quite a lot. We have these coatings which are very well developed. The losses because of the colors is really going down year by year. So we really managed now to have very nice panels where the energy loss compared to standard panels is quite limited. Still some things are ongoing. We are doing research about anti-soiling, some fire issues still. Still one of our concerns. You're working in a building environment which is different than just a standard installation, even on top of roof. In the building skin, you need to be somehow more conscious about that. And then some things about boat glass, very special architectural things where we still struggle a bit. And then, of course, ongoing recycling methods. Just a small reminder, we started from this. When I started, these were typical my presentation pictures. So you have very rude. This is really a picture of me that I made 25 years ago, 30 years ago, something like that. And then we had some autonomous systems. So that's where we came from. Next phase were these kind of things, very big plants. We installed very big plants, for example, in Nakhichevan. Some first demonstrators, and we are really talking about end of the 90s, European Commission installing some standard PV on top of their roof. So that was the status at that time. And then we developed some standardized products. We have Ethernet, Coramic, let's say all the big manufacturers of tile slates have done some trials on this. And somehow it's not going very fast. I mean, it's still bothering me that standard tiles, standard slates are not available in photovoltaics yet. There are a lot of reasons for that. One of the reasons is purely market. If you do something which is, let's say, not fully integrated, you're not in project business, then the price is way more important. And then somehow standard PV becomes so cheap that essentially the standard PV panels are blocking slates, tiles, and things like that to get into the market. And that's why nowadays we work more and more on project. This is one of the examples, for example, technology. This is 2006, and this system has been made with back contact cells. So it's not that the technology is not available. It's just the introduction of the market that takes some time. Other technologies, cutted cells, nice, transparent things. Here, combination of the black parts are photovoltaics, the semi-transparent part are, let's say, with smaller lines, with lines around. So these things are available, have been made, have been done. Of course, also tiles are available. We have a project where we indeed have terracotta tiles installed in roofs, and you barely can see that it's a photovoltaic roof. The colors have all been done. You see this. This is typical what we call isol fresco. That's just a name of the brand, let's call it like. You see all the pictures which we can make, so that's not the issue. Very nice things here. You can have, with these semi-transparent panels, we have really tried all kinds of light transmission, things like that, so really no things. We are still doing, let's say, furniture, which is, let's say, a bit nicer than it was 20 years ago. Nowadays, it's nice, it's integrated, it's in the city. You can have the roads, we have bicycle paths, things like that, pavement, so most of the things are available. Then we go to the validation certifications. Certification as PV is not that much of an issue. Most of the time, BIPV is complying to all certification as a PV element. Also done, a bit more challenging was certification as building element. As noticed before, there are always new rules. Every country is slightly different, so really have to adapt worldwide, but it's manageable. You can do that, it's possible. Some biggest discussion, I think tomorrow, Claire will talk about fire resistance in building environment. So that's still a bit of an issue because the regulations worldwide are a bit different everywhere. So as a company, we are a manufacturer, it's a bit difficult to comply to all these kind of rules, a bit scattered all over the world. So these are all the certifications. You can do complex building, and here it's Ministry of Defense, so you can imagine their safety, regulations, certifications, things that had to be okay before you can supply. We have high-rise buildings. On the building here in Brussels, you see in the greenhouse below on the picture is BIPV semi-transparent, but also the walls, the black parts, the shading elements, even on top of the roof, you see some semi-transparent shading. So this kind of building, center of Brussels, you can imagine, all rules have had to comply to all rules. Same here for Amsterdam. I think it's, I don't know how many floors, but it must be 20 floors or something like that. So it's feasible. You can manage, we can do that. Then we go to the production facilities, and also there I can say, essentially, production facilities are available. I see Necroprogetti is here. They can supply you equipment to produce PV panels which are customized. So it's not just a standard machine anymore. You can make different type of strings, and we have implemented at Soltec also a company, an automated line where we can produce almost any shape, any size of PV panel automated. That means the stringing, the layup, even the soldering of the strings have to be interconnected, soldering, things like that, are automated by machines. And we start from a design. We have a design that we do for the PV panels, which is fully digitalized. You fill in the size of your PV panel, and automatically the program will tell you how to put in the cells, where to put the diodes, where to put the connection boxes, things like that. You can do all that. And then in the end, when that program has made data sheets, and they even produce data sheets, produce, of course, a price. We are a manufacturer, so we need to sell it. They also produce the files to steer the machines. So if there's an order coming in and you have a project with 30 different sizes of PV panels, you don't have an engineer drawing all these 30 panels. No, it's coming automatically out of the program, and automatically the machines will know where to put the cells, where to make the interconnections. So this has been done. So that is something that we have completed, that is possible. What's ongoing are these feedback loops. We learn every day. And everything we learn from power output, from let's say material use, time use to produce, all these feedback loops to improve our predictions, to improve our digital system is ongoing now, because there is still a lot of work to do, because of course production now, I can say we have it, it's available, but of course it needs to be improved to get a lower price, to get more efficiency, to get essentially better products. And then we come to the demonstrators. Also there, I think, there are a lot of projects all over Europe, and ongoing some, I think today is a good example. There are subsidized research projects where we do with demonstrators, where we try new technologies, increase seamless. We all know this project. It's a topic from today. This is, for example, for increase, how we look at demonstrators in a public area where you show what is feasible. But otherwise, you can say there are a lot of projects already available. In Paris, this is a case in an heritage building already. It must be 15 years ago, something like that we did it like that. Here also in Brussels, we have heritage where we have installed BIPV, renovation of buildings, some really nice demonstrators. I don't say photovoltaic needs to be like this, but essentially when you see it and you look at it from a manufacturer point of view, a technical point of view, it's great to see. It even follows the sun, it's fantastic, it's great. And so these demonstrators have been built, and in principle, I would say, well, we have done a good job there. It's also in Brussels, all the shading elements, the black parts, you don't see it anymore. And that's maybe one of the things of all these demonstrators nowadays. BIPV became so good that we don't see anymore that it's BIPV. So it's becoming a bit of a problem for us that we have very nice picture of building like this, where the clients say, where is the BIPV? Well, I have to say the black parts all are BIPV, just for you know. And then the market grow, and then I come to the end of my speech so that I don't keep it long. The creation of the market has been done. We all have these regulations from Europe where we say, okay, we need to go to zero energy building and say it can go a bit slow, a bit faster from country to country. But essentially, I think everybody is aware that in long term, all buildings should be energy self-sufficient. So that's a good rule. So the creation of the market element essentially is there. What's still ongoing is implementation at large scale. And there the biggest problem for me is, and that's what I put there, let's say in dark black big letters, the biggest challenge for us is project engineering capacity. So we have the capacity of producing the PV. We all know how it needs to be done. We all know, let's say, we know how it needs to be done, but our clients, the architects, the engineers, the project engineers, the building construction world still needs to learn how to work with it. So we need to go to education, formation of building partners. Because you have to imagine, for example, we have at Voltaic a capacity of 100,000 square meters of BIPV, which is not a lot if you look at it from a building point of view. 100,000 square meters, not that much. But if you divide that in project of, let's say, 500 square meters per project, it would mean 200 projects to manage in a year. I don't have that any engineering capacity. I mean, we are not such a big team, so we need really to have our market taking it over. For example, here is the timeline of the solar panels requirement by the EU. We know these kind of tables where they say, by this year you need that, by this year you need that. But if you do a project like this, for example, there is some engineering in it. And it's not about the engineer producing the PV panel. It's about the shape of the thing, the cabling, the division of the panels, things like that. And there you need specialized companies to do that, or we need to transfer the knowledge to any architect, any engineering company to be able to go faster to get in. You have projects worldwide, US, but you can imagine for us, managing a project in the US is not that easy. And not from a point of view of production, from a point of view of project management. So the problem is really not the product, the production, it's really the total thing around what we have seen also this morning in the first speakers. It's really that the idea of, you have to look at where do we need energy, how to produce it, how to tilt the panels, which transparency, things like that. And that's taking time and knowledge that is not available yet in the market. A project like this looks quite complicated from a production point of view, because you can imagine in here, if you go from below to the top, every panel is different. These are trapezoidal panels, so you can imagine. But in the end, we managed to produce. The guys making the design of the towers still have to learn that having shadings and things like that is not that ideal. So you have to take into account some basic rules to integrate photovoltaics. This is then the latest project where we are working on in Paris. It's a very big tower. And here, for example, it's a good example where PV will be integrated. There are a few thousand square meters integrated to photovoltaics there. But essentially, compared to the size of the building, it could have been more. But it's because of a lack of engineering challenges that they didn't dare to install more PV, essentially, because they didn't know exactly how it would be. So they do it to say, yes, we did it, but not yet at full deployment by lack of knowledge. I'm quite convinced about that. This is an heritage site. And you see, for example, on the right-hand side, you see typical picture of a BIPV panel. It's not a standard panel. So you need to look at it from the beginning of engineering. How does it look like? How will it be integrated in the total of, in this case, Bruges, which is a protected area, of course. Thank you. I hope I didn't keep you longer than 10 minutes.
Thank you, Stefan, for the good presentation, showing all the capacity of Soltec company to the audience.
That was the purpose, of
I
course.
think we have finished our session, and I invite you to join for lunch break and also for posted session that continues during the lunch, and we'll be back here at 2 o'clock. Thank you to everybody.
So, good afternoon, everyone, and welcome to the session Advancement in Agrivoltaics Among Levels and Disciplines. Let me introduce you the session with just a few words of what we are going to listen to in these sessions. My name is Paolo Picchi. I'm a consultant in agrivoltaic systems at Florence, renewable energy, and I'm also a research fellow at the University of Florence in landscape architecture and dealing with landscape-related issues to energy transition, also with a special focus on agrivoltaic systems. The advancement in research in agrivoltaic systems. If, just for curiosity, today morning I went on Google Scholar and I tried to digit something about agrivoltaics and integrations. And I realized that in between 2020 and 2015 and 2020, the number of publications was around 110. I did digit the same keywords on Google Scholar, agrivoltaic systems and integration, and what it came out from 2020 and 2025, we had now more than 3,000 publications and papers. So this means that this topic, it's really a hot topic in this historical moment worldwide with regards to integration of photovoltaics, integrating photovoltaics in agriculture and therefore agrivoltaic systems. Yet, as the research in agrivoltaics is really multidisciplinary. I mean, the core aspect, of course, is still related in the relationship in between solar energy generation and the growing of crops. So food production from one side and solar energy generation from the other side. But the disciplines that are now interested in agrivoltaics are really more than one. We have agronomy, we have social science. So we have different branches of research in life science in general, so landscape planning issues, but also social science, biology, pedology, who are now interested in this phenomenon of combination of integration on the photovoltaic panel in agriculture. Today, we have a very different and differentiated, so valuable contribution with regards to research in agrivoltaics, though this means that there are so much interest from different disciplines, as I mentioned to you. We have a demonstration today. And so that's why this session, it is called Among Disciplines and Level, because different disciplines and different levels, from the module and interaction plant module level to regional planning, to landscape design, to the engagement, for example, with the local context, are going to be represented among all the different contributions. So thank you so much for joining this session. I have my co-chair, Sergio Mattalucci from PV Magazine. I'm so happy to share this session with him, and we'll be more taking care, since it's a very, very valid journalist, about the question session at the end. Thank you very much. So now the floor is to the first presentation from Next to Sun, the experience of Next to Sun with vertical agrivoltaics project from Marvin Strel-Olow, Next to Sun from Germany. Thank you, Marvin. The floor is yours, 10 minutes. Thank you.
So, perfect, already started. Yeah, greeting from my side. And yeah, first of all, I will tell you a little bit of our company, and then we will go further. First of all, like this. Okay. First of all, what is Next to Sun? Next to Sun was founded in 2015. That year was also where we first installed our first prototype. 3 years later, we had the major advancement with major economic power plant that was installed. 2 years after that, another major power plant followed, leading us to today. We have over 100 employees and over 60 megawatt peak installed and distributed over 50 locations, with even more to come. And here's also a map that shows different locations of Next to Sun in all across Europe, excluding other plants from Japan, Australia, and Saudi Arabia. And yeah, we're also very interested in research, and research is also a very big topic. And we collaborate with a lot of different research institutes, and some of them can be seen here below, here, and are also featured in our presentation here. Moving on to agriculture between the modules. This is how our system looks like. Because we use vertically bifacial PV modules, as you can see at the spaces here. We only have like a low percentage that is covered by the PV modules of around 1%, meaning there's a lot of space left for agricultural usages. And this is really what makes our system quite versatile, because you can adjust the working widths to the machines that are available for the farmers, which is also quite important, as we see later. And there's also no limit in the height of the machines that's being used. And because the machines shouldn't touch the modules, because then it can come to damage, there's also like a 50 to 1 meter space and gap, which accounts to roughly 10 to 15% of the total area, which can be then used for biodiversity measures like flowering strips or biotope structures. This whole system creates a lot of synergies. One of the biggest ones is wind protection, erosion control, and also water availability. And moving on, we had a lot of exchange with farmers in our 10 years histories, and that really helped us to improve the system and see which agricultural machines are compatible with the system. And here you can see which systems are compatible and which have limited compatibility. As you can see, most of the systems really work out very fine with our system. The only ones which are a little bit problematic are the plow, the disc spreader, and also the field sprayer. And one challenge when facing vertical agri-PV is the mineral fertilization, here with the disc spreader, which is like a practice standards in agriculture. And the challenges are that the spread distribution is quite uneven, and the fertilizer granulates sometimes bounce off the modules, and this leads to a very uneven distribution, which is not great because you want to have a homogeneous fertilization. And we thought about mitigation strategies for that, one of which would be like adjusting the inclination to make it a little bit narrower, so the fertilizer granulates don't bounce off, or using this boundary spreading device. So yeah, but that didn't was used in practice, so it's just a theoretical concept. The best practice, what we found out, is using the Formatic fertilizer spreader, because it has adjustable working widths, and also it allows for a very even fertilizer distribution without overlapping. One of the challenges is just the lower availability compared to this spreader, and it needs careful planning when designing the system. Here's also a picture of the Formatic spreader. And one challenge a lot of agri-PV system face is also module soiling, so the pollution of the modules. And the Fraunhofer ISA conducted an experiment where they placed solar panels, solar glass panels, which you can see in red, to measure module soiling. And the interesting results were that, the transmission losses, as you can see here, were quite low, less than 1% for our vertical systems, which can be also accounted to for the self-cleaning effect after rainfall because of the vertical modules. And this is also confirmed with the findings we have from our long-term monitoring, that this really isn't a big issue for our system. A different topic is module overgrowth. Here in the experiment, we did it once with crops, here rye in Wellingen. And yeah, the results were that the module performances correlated with the plant height. So the lower modules, which you can see here in red pinkish, had shading losses because of the module growth. And the upper modules experiences gains, which was quite fascinating. Potential causes for that could be the increased reflection from the vegetation, which lead to a higher module performance and also a reduction in module temperatures. Overall, the performance declined by 1.5%. A bigger issue is the overgrowth by flower strips, because they really have a large impact and lead to yield loss of approximately 10% and can be caused by machine failure or poor management. And learnings are then to adapt the seed mixtures to allow for lower plant heights or avoid over-fertilization of the edge strip. There's also the possibility to use an old grass strip, but these have a lower ecological value. So you have to make sure what you want to achieve with the submodule strips. Because time is running low, I am not able to go into detail into microclimatic. But basically speaking, because of the wind protection provided by the modules and a little bit lower solar radiation, the modules have an improved evapotranspiration, which is just the evaporation release from soil and also the transpiration from water. And it gets reduced by 5 to 40%, which leads to like a higher water availability, especially in summer, and less heat stress and dry periods, which is very good for the yields. But there can also be a slight yield reductions in periods where there's less sunlight. But here we need even more research to consolidate our findings. Moving on to yield results, and here we have a lot of crop yields compared to a reference area, which has no PV modules, excluding the land loss, which is also important to note. And here our crop yields show a big range, ranging from 81% to 127% yields compared to the reference area, which are heavily influenced by weather, soil conditions, and crop variety. On the right side, you can also see these three were heavily influenced by soil compaction, which is interesting to note for further research, how this soil compaction will further affect the yields. But on average, the yields showed to increase by 4%, which is partially explained by greater plant heights to cope with partial shading. Now, finally, to a quality parameter. So protein is usually used for barley as a quality indicator because it determines the feed value, which in turn also affects the marketability and the revenue. And there, our vertical modules showed more or less no difference compared to the reference area without PV modules, which is very good for marketability. And now to a small outlook and a little sneak peek. So we are waiting more results from the soiling trial from the Fraunhofer ISA. Also, there are being some shading net trials conducted in Eringerhof, also in Germany, which also, that site also conducts some seeding rate trials, which is quite interesting to know if there can be made some adjustments. But there's also some upcoming research topics like irrigation system development, and we are also looking for research partners for more microclimate studies. Yes, that was it, and here are some more nice pictures.
Thank you so much, Marvin, also for being time.
Yeah, maybe we have a few questions, but we're going to address them at the end so that also the public eventually can step in if possible. I will introduce the next speaker, Ángel Campos González from the University Politécnica de Catalunya. His speech will be about assessing sustainability and circularity in agrivoltaic system. The floor to you, Ángel.
Thank you for this opportunity. I'm happy to be here in the wonderful Italy. On behalf of my research group, who sends you warm greetings from Barcelona. Today I'm going to present two different case studies with different methodologies that we applied to assess sustainability and circularity on agrivoltaic systems, where, well, on some elements of agrivoltaic systems and the future work we have ahead on our research group. So the first case study is about the utilization of MIBIS, which is a multi-criteria decision-making analysis tool developed by Universidad Politécnica de Catalunya, in which the aim was to decide whether to use wood or steel frames to build the chode section as structural supports for the agrivoltaic setting. So we were assessing sustainability by analyzing three impact categories, which are economic, environmental, and circularity categories. For those categories, we selected 24 indicators, such as climate change or waste recirculation of each material. We have to put a sustainability index from literature to set all the sustainability decision tree. And then, with the help of databases such as EcoInvent, we analyzed both materials. Also, we set five ponderation scenarios, because this decision tree works with a relative value for the impact categories, criteria, and also for indicators. And at the end, results showed that wood section appears to be more sustainable than the steel ones. And I said appears because some constraint remains. For example, the behavior of the wood frames in an agrivoltaic setting due to the humid condition because of the crop growing under the PV panels, and also because this methodology has some limitations. Well, to move to the next case study, that is like a follow-up of the previous one, we applied a life cycle assessment methodology. This is a well-known methodology standardized by ISO and also by European methodologies. Also, in this case study, we added some complexity. For example, we were just not analyzing two materials, but we added scenarios for those materials, for example, for replacement or coating in the case of wood frames. But also, we added two sections of PV panels. The first section arranged in a tracker of 30 kilowatt power opaque PV panels, and the second section of 18 kilowatt power translucent PV panels. So as we were analyzing the life cycle, so from the extraction of materials or of the mentioned elements to the waste scenarios for those elements, we had some interesting results. For example, for the land use impact category, we can see that the wood sections had a worst behavior or results compared to the steel frames. It could be explained because of the necessity of land to grow the wood frames, and it increases if we have to replace some of the frames. And on the other side, speaking about the climate change impact category, we can see that we have similar results from both sections. Actually, the section of opaque, the section of translucent PV panels had worst outputs or results. That because we analyze life expectancy of 30 years. So the energy output was less, so the environmental gains were lesser because of the energy output. So moving ahead, some of our future work is related to our recently inaugurated demonstrator in Barcelona. It is an agrivoltaic demonstrator of 50.25 kilowatt power, where we are both analyzing the crops and the solar generation of 150 PV panels, half of them opaque, the other half translucent. And we are now collecting data to have like primary inputs for new life cycle assessments. But no, we are taking a step forward because we are going to run also a life cycle assessment of the cost and a social life cycle assessment to measure the entire or the global life cycle assessment. We have some work to do about the multifunctionality problem of agrivoltaics because we have energy outputs and crop outputs. And that's all on my side. Thank you again.
Thank you. So for question, please reserve your questions for the end of the session. And now that you have been a little bit comforted from the first outcomes of the two presentations, we can switch to the regional level. So Luca Bozzoni from the region Emilia-Romagna in Italy will present the integration and automation of existing interrelationship processes between photovoltaic technologies, agricultural land production, and landscape protection. This is the GILDA project from the region Emilia-Romagna. Thank you, Luca. The floor is yours.
Thank you for the strongly appreciated invitation, first of all. And my name is Luca Bozzoni, and I work for the Sustainable Agriculture Department of Emilia-Romagna region. more specifically in the field of energy renewable and related to agrivoltaic system and photovoltaic system. No, così alla fine. Sto andando. Sorry. Speed summary, we have 5 key points. A very heated debate about the suitable area in the realization of energy plants, renewable energy source plants. The second point, the control procedure related to certified crop and agrivoltaic plants. The third point is the guild system that consists in a way to optimize and automate the administrative authorization process through the use of low-code platform and the integration of AI tools. We provide a simulation of a part of a typical control problem that we highlight the benefits, advantages in terms of reduction of time and resource effort, effectiveness and efficacy of the outputs, and last but not least, conclusion. Here you can show a legislative work, a national legislative framework. The ministerial decree, suitable area, in 2024, that define guideline for the identification of suitable area for the realization of renewable energy plants. The criteria that are defined as to be followed by each Italian region in order to draft specific law. In the next slide, we have a little reminder about this law that Emilia-Romagna region drafted. Instead, for each Italian region, the value of additional power produced from renewable energy sourced by the end of 2030. The power production burden sharing assigned to Emilia-Romagna region has a value equal to 633 gigawatts. You can show the regional legislative framework with basically with 3 kind of act. Assembly resolution of 23 that call another act of assembly resolution that is 2010, and for what concerns for tiny photovoltaic plants which have to be realized in agricultural area, it states that whereas this area are interested by crops characterized by particular value of excellence, it is allowed to realize exclusively advanced photovoltaic system. The Regional Council resolution on 2024 that defines the typology of crop which are considered extremely valuable and representative of the excellence agricultural production of the Emilia-Romagna region, and define the procedure aimed to control and verify the presence of this kind of crop on agricultural area interested by the photovoltaic project. The regional law, the draft energy law, location of renewable energy plants in the regional territory, aim to regulate suitable, unsuitable, and ordinary surface and area for the location of renewable energy plants, while ensuring that impact on the landscape, on the environment, on cultural heritage, on the local area and the agricultural sector are minimized with particular reference to the promotion of a local agri-food tradition. Further elements of noteworthy importance, regulation of the installation procedure for advanced agrivoltaic system, which include a prior submission of a certified agronomic report, a definition of a forward-looking crop plan to be adapted for a period equal to the system lifespan, including crops suitable for shading consistent with the agricultural production system prevalent in the area. The drafting of an agronomic monitoring report an assessment of the maintenance of the agricultural productivity carried out by comparing the crops present in the advanced agrivoltaic system with the same crops grown without photovoltaic system. What are the certified crops? Organic production pursuant the regulation 84.8, vegetal production registered with the National Integrated Production Quality System, products with origin denomination and geographical indication, the so-called DOIG, obtaining from vegetal production with dedicated production specification, and further cultivating within the original area of the Parmigiano-Reggiano cheese. I think there is not need to presentation about this amazing product. Number of requests state of art of pursuant the legislative act of Emilia-Romagna region in almost 1 year and a half. More than 230 requests from private subject and more than 70 requests for public institution, over 300 in total since May 2024. 4,330 hectares of cultivated land surface potentially interested, and 2.9, a range of 2.9 and 3.3 gigawatts estimated adjunctive installed power achievable from this plant. You can see an example, a simplified process about the requests that received. Requests received by certified email from private or public subject, document registration and archiving. If the required documentation is complete, query multiplies databases to assess the presence and the typology of certified crops among those defined by the Regional Resolution 693/2024. If they are the certified crops, you can or not, you have to drafting and send the operation on the ARCOP in a prepared form. If the required documentation is not complete, an integrative documentation is requested and the tour is start again. What are the human resources currently involved in this complex process? A manager responsible for subscribing and signing outgoing documents, a secretariat responsible for receiving incoming certified mail, assigning them to the correct delegate functionary, two functionaries responsible for the specific matter and for the technical aspect. What's the operational challenge? At present, currently, is a 100% manual process. Two operators must query over 5 databases individually. There is a high risk of human error. Process was through times 1 hour to 1 day for single request. 50 days at maximum to give a response. Tacit approval mechanism become a critical factor as response time lengthening and with the progressive increase in the number of requests. Currently, the process is slow and costly. Operators spend days manually navigating different databases and archive for just one complex case. This slows down the transition and consumes valuable public resources. What are the solutions? Is Gilda, the enabling solution. What is Gilda? It's a strategic platform for administrative workflow and procedures acceleration. The core architecture is scalable, low-code, no-code platform engineering as a single entry point for administrative procedure. The foundational set is built up on a comprehensive mapping and categorization of the entire regional administrative framework. Digitation engine, a robust solution to digitize end-to-end administrative workflow. Centralized knowledge hub, create a vast, unified internal data asset. AI-driven decision support, designed to evolve into a chat-like information repository to support high-level and strategic planning. Streamline stakeholder access, provide a single source of truths for internal staff, user, and key stakeholder. Implementation, we have tried to implementation of specialized AI agents. I want to highlight that we are not merely digitizing legacy process, and I think you know what is a legacy process. We are deploying specialized AI agent to autonomously execute complex multi-database verification, moving from manual processing to intelligent automation. Impact is clear. It's not about eliminating jobs. It's about shifting value. We are freeing our technicians from repetitive tasks to allow them to make strategic decisions, improve the efficiency and accuracy of the service. And now there is a video.
Within the Gilda project, we can see how generative artificial intelligence has been used to analyze the requested documents for the checks needed to provide the results regarding the presence of certified crops. The specifically developed agent is able to retrieve the files related to the requests and verify that all the necessary documentation, particularly the self-certification, is present and has been completed in compliance with the regulations. The agent has a set of instructions in natural language, as well as the information needed to perform checks that are currently performed manually by human resources, a low-value activity. As can be seen in the video, the agent instantly checks and accesses regional databases and compares the data from the regional databases with those from the provided declaration. In this case, for each individual parcel, it verifies its presence in the regional registry database, as well as the presence of certified crops related to the Parmigiano-Reggiano area. As can be seen, the agent immediately detects a discrepancy between the information declared for one of the declared parcels and what is present in the database, and is able to independently prepare a request for integration with the details of what was not provided. In this case, parcel 493, which was indicated in the declaration, is not present in the queried regional database.
The impact, as you can see, the impact is not theoretical. It's immediate and measurable. By transitioning...
Sorry, Luca, I have just 31 minutes.
61 minutes, okay.
Thank
you. We are unlocking transformative gains across three core pillars. Efficiency, minus 95% in verification time, dropping from 1 hour and 3 minutes. Accuracy, 0 data entry errors, and value, staff redeploy from high volume task to high volume decision. This is the path of scalable unified digital PA, because the main strength is inherent in scalability, and you can see that you can start from Gilda core, that is the actual current agri-verification. From step 2 is a unified procedural repository, and step 3 to build an intelligent regional portal. The advantage of a custom headless portal is architectural, strategic, and economics at the same time. And as conclusion, we can say that well-managed agrivoltaic system could be an effective tool for the energy transition. We have to respect to defend the primary role of agricultural production. The Gilda system is a way to optimize and automate the administrative authorization process through the use of low-code platform and the integration of AI tools. Artificial intelligence as a facilitator of the energy transition. This is a final consideration. I take inspiration from a famous offering from a brilliant Oscar Wilde. A grape fruit is a lemon that was given a chance and took it. Given the immense opportunity currently offered by usable technology and targeted design such as the one illustrated, the hope as the challenge is succeed in becoming, in the shortest time possible, is a little less lemon and a little more grapefruits. Thank you for attention.
Thank you, Luca. I think you will be happy to know that yesterday during the Italian Day on Agrivoltaics, during the panel discussion, the former Ministry of Agriculture, Alfonso Pecoraro Scanio, was stressing the need to include artificial intelligence in the authorization of agrivoltaic systems. So I think the day after having a solution ready like this, please allow us to put you in contact immediately.
I think it's particularly important to talk about that in this session. And I will take the chance also to thank my colleague Silvia Boretta because I have a great luck to have her help every day in my job. Thank you very much.
So from a specific case to another specific case, we'll have the presentation of Filippo Lafleur from LAN SRL, who will present a case study on agrivoltaic and as a catalyst of energy and ecological transitions. Please, Filippo.
Yes, thank you and good afternoon, everybody. I think I have a kind of I'm a little bit of an outsider today, as being an architect and landscape architect here in this conference. But I think that it's we're living in a very exciting moment, because also landscape architect now need to talk about energy transition. And so today I will bring you two case studies. One is a personal research I've done for 5 years between a Dutch institution and Italian institution, and the other one is a case study. And they are all within and embedded these two epical transitions that we are kind of surfing at the moment. So the energy transition for us as landscape architect must come within the ecological transition. No ecological transition without energy transition, and no energy transition without the ecological transition. So they're really two structural opportunities. And for us, as landscape architects, landscape must be a platform for sustainable development and for the transitions. And I think that we are here today in this wonderful city and cradle of the Renaissance, also because landscape was kind of born here, right? So the term landscape from the European Convention in the early 2000 was born in this city. And why in this city? Of course, because as the cradle of the Renaissance, landscape was the scale at which to govern transition and at which to govern processes related to the transformation. I've lived personally 7 years in the Netherlands, and this was a book actually that came out in the early 2010 of Emeritus Professor Landscape Architect Dirk Simons, which was talking about landscape and energy and the idea of designing the transition. So the idea that the designers, architects and landscape architects must be involved in this timely process. The first case study that I will present to you, it's called the Super Valley. This is a personal research that I've done in 5 years of research at TU Delft and Politecnico di Milano, which won the first landscape award in the Triennale in June 2025. And it is about the transformation of a mega region that we all know, it's the Pianura Padana. We know this place, and we know that it's a kind of megalopoly of Italy, 25 million people, more than 60% of the GDP. But we know it's a very much still agricultural mega region. Out of this space, which is the lower plain, this is a map, of course, satellite map of the Pianura Padana, in which 83% of the whole space, it's still agriculture. A kind of agriculture that it's mostly industrialized, mechanized, which banalized a lot the landscape after the Second World War, already depicted by photographer Luigi Ghirri, but then, of course, we went with a Dutch photographer all around and photographed this space. And for me, it was important because the hypothesis behind the work was that this place could shift from agricultural desert to let me pass the word desert, to an agroecological energy laboratory. And for us, the energy, of course, it's a key driver of this timely transition. So in order to do that, we tried to pick a transect out of this whole geography, which it's a transect from Milan to Pavia, and we decomposed and recomposed the space. So we identified cells or pixels related to certain land use. And I'm just showing you very quickly how we did the regeneration of the cells. So this is a classical peri-urban cell or portion of the territory. On top left, we see the state of the art of this territory, and down we see the reconstruction, the drawing reconstruction, and on top right, we see a potential transition. Out of these actions, landscape actions that are redeveloping and transforming the space, one of the hypotheses was that agrivoltaic could be one of these action. So at the end, and also we did it here with another cell, which was 95% industrialized agriculture, and we sort of transformed it with the reconstruction of environmental field margins, but also with the reconstruction of agrivoltaic systems. So out of this all, very large, I'm just showing here very, let's say, some screenshots of the research, but out of this whole space, 6% of the total agrarian space in transition for us, it was given, transitioning toward agrivoltaic system. So from normal agricultural system to agrivoltaic system. And then we did some calculations, and I'll just go a little bit quick here because I want to show you that, of course, we did some visual also research on the implications of such transitions, and we kind of deployed this whole reasoning and this whole exercise of decomposition and recomposition of the space in the whole 5 million hectares of the Pianura Padana. And actually, I just want to focus a little bit here on the numbers. Because just transitioning 6% of the agricultural landscape of the Pianura Padana to agrivoltaic, so we are not actually erasing any agricultural system, you're just doubling up the layers, including energy, you can generate 267 gigawatt of energy. And that output exceeds farly actually the 131 gigawatt of which are the renewable energy target Italy in 2030. So this was a kind of investigation or a research project granted by the Italian ministry, and which kind of presented a kind of large vision of the potential of transformation, including energy within landscape and from a landscape perspective. And here I just want to show you quite quickly a very concrete case study that we've done with Land. Land is a landscape architecture company. We work at the international level, and we are trying to bring forward this paradigm. Andreas Skipper, which is our CEO and founder, is also in the committee of the World Economic Forum for Nature Positive Cities. And we're trying to always tell our clients that net zero, it's not enough. Do not significant harm, it's not enough. We should do significant improvement. And this is what I think the change of paradigm should really be, from net zero to the nature positive. And also increasingly the literature is telling us that we shouldn't talk about climate alone. But to talk about climate is to talk about nature, biodiversity, and climate altogether. So I think that we kind of drafted in a diagram here how the old approach from energy is going toward a new approach. So the old approach was that energy was kind of was erasing nature and also sometimes people from its places. This is the kind of industrial or extractive paradigm. While we should have a transformative approach in which nature and people and energy kind of thrive together. And here I'm just gonna tell you in a very concrete case study what we did. So this is an agrivoltaic power plant in Castelguglielmo in the province of Rovigo, Veneto, close to the Po Delta. And the client here was Repower, Swiss energy company, that decided to revamp a photovoltaic system, an agrivoltaic system toward new futures. And of course, we added the landscape component to this already existing power plant. So here is how it was yesterday and how it is today. It's 34 hectares. And this was our master plan. So again, here we try to incorporate the ecological transition within the revamping of an existing energy infrastructure. So you see here three colors. One is about ecosystem rehabilitation. The other one is about socio-economic activation and cultural activation. And the other one is about the recognition of repower being in the landscape. So the identity also of the owner of the power plant. So the project was divided in four main points. The threshold, the central spine, the square, and the farmstead entrance avenue. And I'm just going to show you very quickly what we did. So this is a kind of photo montage and render of the gateway of the spot. So what we did here is that we worked with some landscape elements such as trees to reconstruct a bit what it was. Some trees to kind of mark the enter of this power plant. Also the central spine, which was kind of eroded from nature, it became a kind of ecological boulevard with also the rehabilitation of some wetlands. And the square also becomes a space in which to stop and recharge. This is within some very scenic bike routes close to the Po Delta. And this was the regeneration of a wildflower strip within the energy power plant. And I just want to close here saying that I think that for business, it's important to recognize that ESG and what the whole world of sustainability shouldn't be just about compliance, but we can do more and we can rehabilitate and measure the positive impact that we can produce on the landscape. And I think that what we said to the client here that was interesting is that we composed a measuring framework, which was divided in environmental, social, and governance to kind of measure the impact of their project on the landscape. So now we're going toward execution. And I just want to finish with this, which kind of puts together the vision kind of project that I shown you at the beginning, and this more concrete project for the energy transition. Thank you very much.
Thank you. Thank you, Philippe. Just for you to feel more comfortable, I'm also a landscape architect, so you are not the only one, also other colleagues here in the hall. Good. So now we pass to Eficia Martinidou, right, from Hope, Greece, and the title of our presentation. So we go back to technology. Now we are being seen a little bit more integration, spatial planning, landscape, and now we go back to technology on the triple use of land with semi-transparent organic photovoltaics for agriculture. Thank you.
Well, not just technology, also social acceptance is a quite new concept we're posing here. Also beauty, architecture, that we will talk about all of this, but I will focus mainly also in some experiments we did in our Agro Hub and in agrivoltaics and in cultivations below organic agrivoltaic systems. So thank you very much for the kind introduction. Unfortunately, was a co-author of the abstract that we sent. The head of AgriBiV's department couldn't be here today, so I will be presenting on their stand. And I am Innovation Business Manager in Hope. And before starting on with today's agenda and going deeper into this new technology, I would like to take a briefly moments to introduce in general who we are. So HOPE, which stands for Hellenic and Organic and Electronics Association. It is part of the International Tech Hub Thessaloniki, which is a globally recognized ecosystem that brings together experts from the field mainly of nanotechnology and advanced materials. It all started back in 1991 from research from the Nanotechnology Research Institution LTFN from the Aristotle University of Thessaloniki, and since then it has brought together many people, many different experts and specialists, and not just in the field of nanotechnology, but in the whole production chain, also in materials, marketing, and business development. And we are mainly focusing on working not just in green technologies and in photovoltaics, but also in biosensors, in lighting, in smart packaging, in the Internet of Things, a lot of things like together. And through all this effort and all those experts working together, what we actually want is to bridge the gap between research, innovation, and industry. That's why we have so many spin-offs and new startups, especially coming from the research lab institutions in our team. So also before starting, I would like to say that most of the experiments I will show today and most of the demos and illustrations are part of the Flex to Energy project. It's a European Horizon 2022 project that brings together more than 17 partners from Europe from 8 different countries: Italy, Spain, Germany, Lithuania, Greece, and of course we also have Romania. I'm sorry. And yes, and what we want to do together is to finally go from pilot lines to mass production. We are all together manufacturing the first in the world now based in Europe manufacturing and production line of organic PVs. So we heard a lot here today about photovoltaic systems. We all know there are third generation of photovoltaic. The first generation is the silicon type that we talk a lot about today. We have also the second generation, which is thin films. And now we are into the third generation, which includes perovskite as well and organic photovoltaics as well. I will be diving deeper with this. Mainly I will talk here about 2 main products and organic photovoltaics and how we can integrate it in buildings and in agriculture. So the Apollo line is mainly for agriculture infrastructures, while the Futura is more transparent, is more clear, and we basically use it in buildings because you have better visibility. There is a variety of colors. They're very lightweight, less than 0.5 kilos per square meter. And they're flexible, rollable, bifacial, so they can produce energy for both sides. Also diffuse lights, even technical lights, not just sunlight. And they can also be used indoors or in facades. And we have many applications. And so these applications, they are like extending from agrivoltaics that I will be mainly focusing today on, and to BIPVs, which we cover tomorrow. But we also see in urban infrastructure and smart cities, like we said, in mobility, in tourism, in wearables, and smart textiles, which is something very fun. We have some smart bags we're working around, and also in defense. Now moving on to the main subject of my talk today, that is the food security issue and how agrivoltaics can help us with all of this. So it's true, and we hear also today with many of my speakers, we have to do more with less. We want more. It's good to have more. We know that by 2050, the world population will be around 10 billion people. So we have to produce more than 70% of what we can manage to produce today. At the same time, climate change is bringing us with many issues. There are extreme events. There is land degradation. So with the land that we already have, we have to find a way to produce more food. At the same time, agrivoltaics and photovoltaics are in the picture. So the last thing that we want is to have perfectly arable land turning into solar farms. And that is exactly what agrivoltaics are, is the dual use of the land. We have both photovoltaics and energy production, and at the same time, we also have food production. So I won't spend so much time here for the types and forms of agrivoltaics, because many know way better than me. But in general, I will talk about integration not just in greenhouses, but also implementations in open field cultivations. Also in agrivoltaics, we have different types of agri-PVs. We have the silicon type, we also have thin films, and we are also working now with organic, because the main issue, I would say, agrivoltaics have some microclimatic benefits. So we see that cultivations below panels, many also spoke about that before. So they help with water scarcity, because the canopy and soil moisture can below the shade is maintained quite well, and that is very important for Mediterranean regions and especially for semi-arid lands. So we have like the temperature drops 1 to 2.5 degrees, depending on most of the research, below the shade of agro-PVs, and so we have less evapotranspiration, the plants lose less water through the leaves. That's good for water consumption, and it's also good for UV radiation. So we see that heat stress is reduced, and that's very good for some shade-tolerant crops. But what we see in general is that crops, and especially sun-loving vegetables that we see often in the markets, or very economical important crops like cereals, we see that when we put those together, there is a reduction in the production. Small or big, it depends on a lot of things. There are like so many research regarding, but in general, we see that the production in the food is reduced. So the interesting thing about the organic PVs now is that they have a great transparency. So they allow at least 40% of the sun to pass through. And what we have seen through many experiments is that since they filtrate also UV and IPAR radiation, they still allow, and that is the interesting of their manufacturing, how they are created, they allow PAR to pass through. That is, the photosynthetically active radiation will help all plants to photosynthesize and grow. So with all the benefits that we've seen with other agri-PV systems as well, which is the microclimate and the water scarcity, they also have this benefit. These are some of the demos that we have here and some of the experiments that have been done mainly in cucumbers, tomatoes, eggplants, and also in open yard in grapevines. So the systems are very lightweight. They are very easy to integrate inside the greenhouses or outside the greenhouses. And they tend to protect the plants from harsh conditions, from extreme heat, from extreme UV ray, and they also help with the microclimate inside the greenhouse and outside as well. And we have seen that we have larger crops and also like heavier average mass by integrated them in the preliminary experiments, exactly because of all the benefits. And we also see that they are capable of dropping the temperature below those panels. We have seen that before, but the max difference that we saw was 4.5 degrees, especially in summer, which is quite important. We save energy by this way because we don't need to use all the other things. I had some videos here to play, but I didn't. But it's okay. Thank you very much. I tried to be very on time. It was a lot to cover up in just 10 minutes.
Now, the last contribution. We will have Davide Sgambato from DG Twin. And he will be speaking about data-driven analysis of crop yield in a controlled agrivoltaic installation. Then start thinking about your questions next, because we are going to address questions to everybody in the panel. So just, If you have any, don't feel too shy.
Thank you. Hello to everyone. I am Davide Sgambato, and I'm a mechanical engineer and energy specialist at DigiTwin, that is a spin-off of CNR of Naples. In this work, we speak obviously about agrivoltaics. As you know, climate change can severely damage crops, mostly in very hot regions and cities. But there are some crops that, in specific shading condition, can improve their agricultural yield. So the aim of these studies is to create controlled microscale agrivoltaic plants to understand the effect of shading on the crops. This study is part of a RACE project, where RACE stands for Real-Time AI-Driven Yield Optimization in Agrivoltaic Systems, and is co-founded with the FAIR, Future Artificial Intelligence Research, under Italian PNRR. In the first part of RACE project, we developed many numerical models because the objective was to build a multi-objective optimization to find the best agricultural to find the best agrivoltaic plants that maximize both agricultural and energy production. We developed radiation model, PV power model, PV shading model, and the last one is a crop yield model. In this slide, is showed the result for a Basilicata case study, where variables are PV tilt, PV area, and PV8. We obtain these Pareto fronts, and the optimal point was chosen with the utopia criterion. The crop cycle hypothesized in these studies is this reported in this slide, and is lettuce, broad bean, tomato, and spinach. The optimal point represents an annual energy of 391 megawatt hours per year, and delta crops of minus 7.6%. But if we watch tomato, yield increase over than 30%. In parallel, we developed a microscale agrivoltaic plants in which there are 6 boxes that are divided into groups. In every group there are one box with no PV that represents standard agriculture. There is a box with full shading PV and one box with 4 small PV on the corners. In the microscale plants, there is also a meteo station with the environmental sensor, and in the boxes there are PAR sensor, where PAR stands for photosynthetically active radiation, and there are soil temperature and moisture sensors. This sensor communicates with central units, and this data was sent to a remote server. And with this sensor, we enable precision irrigation. We developed also an AI tool that takes in input image of the box and takes in output the green percentage of the box. So in these two graphs, there are green percentage of the period that goes from May to June. In one group of boxes, there are strawberries, and in the other groups, there are zucchinis. We can notice that Box 3, that is a box partially shaded, represents both for zucchini and for strawberries the best, the higher value of green percentage, while the full shaded box represented the lowest value. This is due to several disease of box 3. Oh, yes, of box 1. Sorry. Our experimental data were there was with the meta-analysis founded in the literature, we can see that both for zucchini and strawberries, curves match with the first curve of Laub et al. Meta-analysis, which represents crops that improve their yields under specific shading condition. Now we are working on machine learning and prediction model to predict environmental parameters. And we are working on a smart solar tracking prototype, which is AI assisted and can change tilt of PV with the real need of the crops. So in the conclusion, we can say that in this study, we can say that there are specific crops that under partial shading can also improve their agricultural yield. So with agrivoltaics, with the same land, we can product energy, we can have food production, and we can also improve agricultural yield with the specific crops under specific shading. Thank you for your attention.
Just a small reflection that I would like to share with you. We have been listening a lot about doing more, which is definitely something that we should do. But also we see that on a political level, there is less and less an interest for climate and environmental policies. So one key aspect that can slow down installations of Agri-PV, but also in general of the energy transition, is for sure the social acceptance. So one first question to all the people in here. So what are the specific factors that you think might increase social acceptance of locally developed or locally installed Agri-PV systems? Is there any specific element that you think might increase this sort of acceptance? And we have also a very interesting perspective, because we have a Greek perspective, we have a German perspective, we have an Italian perspective, we have a Spanish perspective. So altogether, how do you see from your specific perspective the landscape, but mostly the social acceptability of Agri-PV projects?
Thank you very much for the question. I wouldn't say that it's just based in one country, but I would say how was our impact while going all around the world and talking about this project. It seems that people are generally surprised and they really like seeing that they can do dual, have energy at the same time, maybe also improve cultivation. So in general, people are exciting. They think there is something new. But of course, the next questions that come always is the cost, or how easy it is to integrate them in the system, and what is the policy and the regulation regarding all this. And the problem here is that when we're talking about innovation, normally the price is not as easy to be integrated. The government and people have to help, or maybe with projects and with some regulations or tax refunds, people to do the step and try if this has worked and how they will be benefit for it. So first, economical impact and governmental issue is the thing. And then in general, what I see is, and we were discussing that last week as well, there is not uniformity in the regulations here, especially about agrivoltaics in general. We see so many different aspects from so many different countries. And for example, in Greece, there is not a clear regulations regarding how much photovoltaics and how much of the land have to still stay like agriculture. We agree that dual use land should primarily be agriculture. But for example, India is not really the same. They have a totally different system. Germany allows 90% cultivation, only 10% agrivoltaics. Italy, I think 70 or 80, the last time I checked. In Greece, there is no law regarding
Well,
that.
in case of Italy, laws change very quickly.
Yes, of course. So I would say that these are the main issues I see when I talk to people. I don't know what the others think about that.
Yeah, thank you for the question. I agree with the governance issue, that it's important for agrivoltaic social acceptance. I will add, for example, the agricultural retention of the system. We here in Europe, we have, for example, protected origin crops, and it's important for the community to participate on the planning of these systems. It seems pretty easy to say. It's difficult on practice. I will add other thing, because yes, I live in Spain, but I'm from Panama. So speaking about social acceptance of this kind of systems, we can see in Latin American countries, I would say mostly of them, we accept very quickly solar energy projects, because we think they are green, and yes, they are green, but as one of our colleagues just said, it's not just about net zero, right? And it's important to not deploy or massive solar energy projects with the cost of losing agricultural land.
Thank you so much, Angel. If you can go on with the answers, if possible, within each of us should have 2 minutes so that we can maintain and have space for other questions.
Okay, I try to be quite quick. From my perspective out, I go a little bit like to the perspective of the farmers, because that's something I'm more, I have more knowledge in. So far, they seem to be very accepting of the systems, but there are like several things which are really important for them. First of all, is like if there is an economic benefit, first and foremost. If there's none, like the acceptance is quite low to do it. Then also another thing is really like, is it easy to integrate into their already like practices that they already have been doing for years and maybe generations and even longer. So there really needs to be a system which is quite simple to implement, otherwise, or not too complicated, because then it can make life for the farmers way harder. Yeah, that's all I want to add.
Yes, I want to add just one thing. According to our studies results, we noticed that partial shading can improve agricultural yields. So with the same land, we have food production, energy production from PVs. So the question is, why not agrivoltaics? There are only benefits.
Thank you for the question. May I can answer to the last intervention. Why not? Not why not exactly. What are the weak point to increase acceptance as you requested? There are a lot of work to do, again, more, because from the point of view of legislative framework, for example, we have only, in Italy, we have only some guideline. We have not exactly a legislative framework where exactly define what is agrivoltaic. Okay, like as technician, we know what is it, but you have also to include in a legislative word and not only in some guidelines that have not effect from the legislative point of view. A second point is to be sure that the quality of production, excellent product, like in Emilia-Romagna region, but the same example you can do in North Italy, they have not damage from a more shaded, for example, cultivation. And what are, to be sure also that you have no damage in the land where you have the panel, the photovoltaic panel, for instance. These are 4 or 5 key points that I think you have exactly again solved.
Actually, thank you very much for the question, because I think it rises up a fundamental issue that we're trying to address, I think, also in this conference, which is about the integration of different disciplines. We all, I think, remember the NIMBY of the early 2090s, not in my backyard, right? So no one wanted a carbon coal power plant in their backyard. No one wanted a gray hole for water harvesting in their backyard. When we designed a park for water retention in the Lura, north of Como, everyone wanted it again because it was a park. So I think that the same is happening now with energy. For the project the way I showed you in Rovigo, we had as a case study and inspiration a Dutch agrivoltaic project in which the agrivoltaic power plant was integrated with a park. So it was a very suburban kind of area. So the park was integrated, and actually the power plant by the business, the operator, was co-designed together with the local people. So I think that it's again about the integration of also the different disciplines that it can rise the acceptance.
Well, it sounds brilliant, and like just to sum it up, it looks like it's needed to have sort of participation from the local communities within a framework that is governance rich and aware, that gives economic benefits, and that is simple enough to be integrated within the workflow, but at the same time that grants quality of food production, thanks also to a strong legislation. Then, of course, like we've heard that in Italy 2 days ago, there was an integration of agrivoltaic that it was finally defined, despite the fact that, yes, I mean, there were a lot of holes in the legislations, and there are still some, but hopefully there will be some positive developments in this sense also from Italy. Paolo, do you want maybe?
If there are questions from the public here, are there any questions? No, I have some curiosity. And first of all, I wanted to ask a question to Filippo, because I was very curious about the percentage that you calculated of 6% in the Padana Valley. What landscape parameters have been used to calculate this 6% as suitable for agrivoltaics? Because, for example, we know that Enea did release a map the whole Italy suitability, for example, by using quantitative metrics typical of landscape ecology disciplines, and they did their own potential map. So I wanted to know, how did you reach that 6%? What's the added value as landscape architect to work on that? Yeah, thank you.
Yeah, thanks. I think we can also have a separate conversation on because it took a long time as a process, and there is a whole methodology behind it. But I think that generally 6% was out of the agricultural space in the Pianura Padana, which was at the moment arable land, so under arable land, which was around 4 million hectares in the whole lower and higher plain. And the suitability, so if you erase the areas which are nature conservation areas, you erase the built-up areas, and you come with these agricultural voids or desert, then for me it was a process of design, so of integrating different components, and the 6% was just a kind of a random result, that 6%, which came out of a design process. So after a design process, I came to realize that it was what I designed, it was 6%. But it could have been more, it could have been less.
Did you have design samples all around somewhere? Or, I mean, what do you mean by designing? I mean, you giving a certain orientation to the layout of the PV arrays or the trackers, or?
So I designed one sample of 25 hectares. And the assumption was I took a sample or 5 different samples, which spatial qualities and spatial quantifications were ubiquitous in the whole Pianura Padana area. So for me, the sample was as a kind of fractal, you know? I couldn't design...
design prototype.
Exactly, a design prototype.
Okay, thank you. Other questions?
If there are no other questions from the public. Oh, sure. Please.
What's the impact on
Well, yes, I mean, I can answer to a first question. Like, there is a strong correlation between the increase of pollinators and PV systems. Like 2 weeks ago was released a research, an academic paper, saying that under the PV systems, ground-mounted, there is an increase around 160% of pollinators. But of course, then experts can give more nuances and more details if they want.
Still to my knowledge, because I know that, yes, the pollinators, it depends also on the panels, but when you have also wild or patches with wild flowers, it also helps, along with a microclimate. So with bees, they saw that there is some good effect. But once again, we are talking about really large surfaces, which normally doesn't happen in agrivoltaics, because we want to retain the surface of the PVs. And I'm not working with silicon, so maybe I'm not the best to answer this question. But when we're talking about solar parks, and that's the only one I know personally, is with the reflection, like the reflection that you have in the panel, is not the best for orientating animals. But that is for solar parks. It's something completely different when we're talking about agrivoltaics. So in agrivoltaics, we see that there is a lot of systems that they are doing grazing lands. So farm animals are below the shade of the agrivoltaics. That's what I've read up to my concern. But when we're talking about solar farms, indeed the reflection of the panels can create some problems. But agrivoltaics, the design is really specific. We see some benefits with the bees. There are farm animals that they can stay below agrivoltaics. That's what I know and what I've read through papers, but still I'm not working so much with silicon, but that's what I've read. So for agrivoltaics, it seems that there is not a huge effect to my nose until now. Normally, really large surfaces and solar parks can create problems to animals because of the reflection of the light, mainly when we're talking about birds. That's what I've read in papers. Someone else wants to.
I could add to that depending on what species you're looking at and to what systems you're comparing it, agrivoltaics can have like a huge impact. And if you're looking at the landscape level and you have just like conventional agriculture, usually agrivoltaics or like conventional photovoltaics tends to square better because then the area gets extensified. It's mainly, in most cases, there aren't that many pesticides used in agrivoltaics or like on the conventional areas. So that's all beneficial for the animals being there. And there have been also some monitorings conducted with bird species, which actually benefit from botanics and agrivoltaic fields, because there were more flowering strips and more habitat structures around that area, which used to be only conventional agricultural fields with no habitat whatsoever for the species. So it was very beneficial. But yeah, also if you compare it sometimes with large animals and large sites, it can be an issue, because then it can act as a barrier. But to mitigate it, you can also, in your system that you're designing, like find structures for large animals to go through and have areas to traverse the lands. So it's more like you have to take that into account when designing your system. And then it can be very beneficial, in fact, for the animals.
Thank you. If there is more interest in the questions, we also invite you tomorrow afternoon on the parallel event. It's an expert panel organized by the University of Florence, and we landscape architecture program, and we invited zoologists to discuss about this interaction between fauna and also agrivoltaics or photovoltaics. So if you please check the program, if you're interested, you can join the parallel event.
There's another question there.
Yeah, thank you. I think it connects to kids. I people say, let's look it from a broader perspective, not only climate, but biodiversity and nature. And I heard some other people say, if there's no business case, it will not fly. I like the remark from Filippo. But I also like the thinking about the business cases, but because it's reality. And how will nature will never have a business case. How will those worlds ever come together?
I'm not quite sure. Is it a question? And so the question is it possible to combine business case? Whoa, that's a difficult question.
Well, maybe I can answer, certainly try to answer. I mean, there is new research and new opportunities where you see that agrivoltaics are well combined with sustainable practices in agriculture. Agrivoltaics, it means agricultural land use, not nature. And there is quite evidence right now in research and first applications that there are good, it's a good combination in between agrivoltaics and regenerative or sustainable agricultural practices. For example, in northern Italy, in Piacenza, we have one of the first pilot plants from Rentec that was built in 2010. I did a personal interview with the farmers 1.5 years ago, and they started, since the agrivoltaic system is insisting over there, applying regenerative agriculture, so minimum tillage, less watering. And so we could foresee that in that case, of course, according to the standards in regenerative agriculture, just because you are doing minimum tillage in your agrivoltaic systems, the biological quality of the soil will improve, and the vegetation on top will improve, And so that's the way agrivoltaics can go together with ecology and with nature, but it's still the nature part of agri-environmental systems. So it's not just nature. If it's nature, it's not agrivoltaics, it's another stuff. But if it is in nature, it must be combined with the practices of the farmers who are doing regenerative agriculture. Yeah. Thank you.
So basically, we will be done, but since we don't like coffee and coffee breaks, just a quick question to everybody, if possible. You are a panel of relatively young adults, and this is very good because as I've seen, the people that are mostly interested in agri-PV in Germany, where I've been living for 8 years, were mostly farmers, young farmers. So 2 questions. First question, do you see a higher inclination, proclivity, acceptance of young people towards agri-PV systems? First question. And second, do you think that there are enough young farmers in your country, or that you have been working with, or that are possible clients of yours?
So I will mainly speak for my students or the people that I'm working with in the research, and most of them were quite young. And what was that brought us together is the combination of innovation, like we said, research, but at the same time, climate benefits, because there are many pillars in the agrivoltaics that are in coordination with the climate smart agriculture or with green energy practices. So that's what also brought us together. Alongside with, especially in our case, because the product or the innovation product that they had, we also in combination, my first degree is in agriculture, but we are working with a lot of physicists as well and a lot of engineers and architecture in the field, let's say. For me, it was also nice the fact that we could combine or maybe also improve food and cultivation and like help also some plants that are struggling with heat or like VFS depending. So the benefits on microclimatic conditions, the social benefit, because we're talking about renewable energy here, but in a sustainable way, because sometimes we talk about renewables, but we don't think how much it costs to make these renewables. How are we recycling or reusing these renewables? So there is like too many aspects, and it's a very big conversation, but I will just keep it very short and say that yes, young people are very interested in sustainability, they're very interested in green practices, they're very interested into doing the best they can with the environment. That was also our aspect. Unfortunately, in Greece, we don't have so many younger farmers, and that is the issue, but whenever you say young people, they won't, I mean, even if the money, even if there is like, because older people are more skeptical, even they are more ready to take the risk as well. I mean, in the business or in the research, they're more interesting to do a pilot or try together or do some research together, because we are dealing with some clients, but we also are talking mainly about scientists and researchers here as well. So yes, young generation, young people are very interesting. That's what whenever I'm talking to a student, that's what my intake. In Greece, there is a lot of people outside Greece, young people outside that are doing a really good job, not inside Greece as much. And yes, we see older farmers mainly. There are some young farmers, but they're not as much as the older ones, I would say, as the older generation.
Well, on my side, I see agrivoltaics like an opportunity to actually retain young people on agriculture, because of the possibility to have new revenue incomes on farm. Regarding the other question, I don't have a big picture about Spain, young people on farming, so I'm gonna speak about Panama. We are a country that are importing like 95% of agri food. So we don't have a lot of interest of young people on agriculture. We focus more on logistics about the Panama Canal commerce. So link with the first question, I really see this like an opportunity, because actually I was speaking with a Colombian colleague here that our countries, we have better radiation. So we have like both opportunities on crop growing and solar output. So yes, thank you.
Yeah, I'm quite new to this topic in general, so I cannot really give a precise picture on that. Just from the experience I have from work in the company, which is mainly like focusing on agrivoltaics, we tend to have a very young team. So from that side, it's already like very refreshing to have a lot of young colleagues as well. And from also the university kind of side, there have been a lot of interest from other students in that kind of topics, and they were very eager to learn a lot more from agrivoltaics and also from their own initiative without even like having like prior knowledge in the fields of either photovoltaics or agriculture, and they were just like super fascinated by everything. Yeah.
Yes, I can speak for myself because since I was a kid, I always want to live in a better world. So and that's why now I am a mechanical engineer for energy and environment. And I think and I hope that there are many young people, children, students that thinks about it. And I think that agrivoltaics can help to go in this direction.
My cultural background as engineer, energy engineer, of course, is can consider an agrivoltaic like an opportunity, of course, in my opinion. Anyway, as I shown in my presentation, I manage the procedure of control and verification about the presence of certified crops. And so we have to conjugate this exigence about energy production with the defense and protecting certified crop for Emilia-Romagna region. I have no direct link, even if I receive a lot of calls of email and about age of stakeholder, but I am convinced that young people, young farmers, are more agree with agrivoltaics than oldest people.
Yes, so I think that it's good to have, I think, more young people on the land as a kind of process of reappropriation of ruralization as opposite to urbanization. But yeah, I think that I just want to go back to just as a closing remark to the question of the gentleman in the audience, because I think it's very much to the point of that I think the business world should look at nature as a competitive advantage, not just as a thing that I do for marketing. And I just want to make a very quick example. So if I am the business operator of an agrivoltaic system and I shift to regenerative agriculture, then I'm not using synthetic fertilizers, which it's about resilience and it's about business competitiveness, because I'm not in that supply chain, which is a global supply chain, that if something happens to Russia or Ukraine and I don't have that fertilizers. And I think that in the past 5 or 6 years, we have multiple examples of that. So, and I think that resilience, that for years was a buzzword, we can see it very pragmatically here. And I think there is a lot of young people that are shifting to regenerative agriculture, and I think that agrivoltaic, it's something that I hope they will also incorporate in their land stewardship. Well, so we are running out of time. Thank you so much for your time and attention and experience. You shared it brilliantly. Thank you so much from my side.
Thank you to all the speakers for integrated contributions, and thank you for the audience. And let's go now for a coffee where you can further take advantage and maybe have a more conversation with the speakers, with ourselves. Thank you.
Good afternoon. Yeah, much better. Well, let's start with the last session, which is about the vehicle integrated photovoltaics. With me are three speakers representing three types of companies, Lightyear, EM Efficiency, and OPES. So I think I'm not going to do a longer introduction. I think it's much more interesting to listen to the speakers. So we can start with the first speaker, who is Rupert Kogla. He's the business development and technical sales at Lightyear. He has more than 10 years experience in both IPV and vehicle sector. So he has an interesting mixture in this experience, and for sure will be quite interesting what he has to tell us. So the floor is yours, Rupert.
Hello together. Good afternoon. Thank you very much for joining the last session. And now let's see what we can show to you. And the topic, as mentioned, vehicle integrated photovoltaics, some kind of integration of PV. This is what everybody is kind of driving us. And my name is Rupert Kogla. I'm at Lightyear. It's a Netherlands-based company. And our task is, or what we are kind of focusing is clean energy for everyone and everywhere. Lightyear, maybe somebody already know that company. There's a past. Lightyear. Lightyear has developed a solar car, but today we are focusing on the components of this kind of mobile applications. This means we are trying to convert every surface of a car into a solar active area. The second topic, what we are kind of focusing is the most efficient electronics to utilize that energy. And the third area is to get an interaction to the customer, to the end customer, by a sophisticated HMI system. So, what are our main topics? First of all, when you're speaking about vehicle integrated photovoltaics, you have to integrate solar active elements, means the solar module. And that solar module is, as everybody knows, it's dependent on area. So the more area you can utilize, the more power you can integrate, and therefore over the year, the most energy you can harvest, which gives you the advantage of having kind of free energy on board by not getting connected to any infrastructure. And this is kind of interesting when you're looking forward to the electromobility penetration in the market. You also have to have a kind of charging infrastructure. And imagine you have a vehicle which is charging itself every day by around 10 to 20 kilometers. So you don't have to look for a charging station. And this gives you some kind of release and some benefit. The second topic is the power electronics. Yeah, everybody knows about this MPPT tracking systems, and there we are working on systems which makes it possible to integrate that PowerPoint tracking systems into very complicated EE architectures of cars. What is the challenging part there? So we would like to charge the high voltage battery. And this high voltage battery has a very sophisticated safety system, meaning when you're charging a high voltage battery system with 100 watt power, only the safety system to be switched on is consuming more in comparison to what is delivered. And there you have to find an architecture which makes it possible to make that system as efficient as possible and also fulfill the regulations concerning safety. So this is the most tricky part there, because it's not as easy kind of installing a PV system and charging the energy to the high voltage battery. And the third topic, as I mentioned, is the HMI, human-man interface, which gives the driver the possibility to understand how much energy is he consuming depending on his driving behavior, but also how much energy can the car harvest over the day. And we believe that it's very important to give the owner or the user of that car that information, because at the end of the day, having that person, that information also, we think, will change the behavior. So he will take care about his style of driving, but also he will take care about where he will park the car and how he utilizes the complete infrastructure. And having that 3 columns put together in the optimized way, this gives you the benefit of reducing the moments where your car has to be connected to the grid. And what we see here is that you can save around up to 30–40% of your grid-connected charging events, which is obvious a kind of very comfortable feature for an electric. When you have you ever driven an electric car and being in a city looking for a charging station which is free, especially when you're at the evening coming home, it's kind of comfortable knowing that you also have an opportunity which is kind of independent from the grid. Okay. In the panel discussion before, there was also the topic of the social responsibility or the social impact discussed, and this is kind of a slide which shows what is the advantage of this kind of vehicle integrated PV. When you're charging your battery with solar energy, you can, in comparison to a standard D-segment battery car, you have an around 30% better CO2 footprint. Second, you have that advantage of that less grid capacity, means the charging infrastructure means building up charging stations, building up new power lines can be reduced. And over the lifetime, you have a kind of total cost of ownership calculation, which brings you saving. And when you think that further, you don't need the highest battery type or the biggest battery type. You also can start to think about downsizing your battery size, which again increases the efficiency of your car. And so then you're kind of going into the direction of very efficient mobility. When you think about and seeing that car, there's the vision of the cities of the future, yeah, and it will not be definitely that big SUVs are powered by electricity in the cities. What we are kind of envision is there's a kind of micro-mobility approach, means small cars which are very, very efficient, not having big batteries, but try to focus on the efficiency, which is kind of benefiting everything, because this means the car is smaller, the efficiency is higher, you have a much, much higher flexibility, and also the investment should be much lower in comparison to what we know today. Let me show you some examples where this VIPV already have been integrated. So on the left top side, you can see a product which is already 35 years old and was sold around 350,000 units. It's a tilt-slide solar sunroof where this energy was used for powering the HVAC ventilation. So when the car was parked, standing in the sun, the energy was used to running the blower and keep the car cooler. On the bottom left side, you can see a product from Hyundai. Also on the top right side, where there's around 200 watt peak of solar power integrated. That energy is used for charging the high voltage system. In the middle, top, you can see already a kind of micro mobility aspect. So there's maybe you've heard, or there was a former approach by Mercedes with the smart car to go. This was a kind of mobility approach where in dedicated cities that car have been placed, and you were able to enter that car and use that car. Also, these cars had some solar panels. And there's the interesting approach on the right bottom side. This is the Panda Nuevo, where there is, I think since last year, there's a kit available where you can kind of retrofit your Panda to an electric car. And also this electric car can be equipped with a set of solar panels to support the range. Thank you very much for your attention.
Well, we are going to continue with the presentations, but at the end of the three presentations, we will have the opportunity. I will give you the opportunity to ask whatever you want. So please keep your questions for the end. And the next speaker is Robert Hendel. He's CEO and founder of OPES Solutions. He has been working in PV since the 90s, so a lot of years. At 2012, he founded OPES for manufacturing modules for integrated PV applications. And since 2017, OPES is mostly working in vehicle integrated photovoltaics. So, yeah, the floor is yours.
Thank you very much for the introduction and having me here. Good afternoon, everybody. Before I start, maybe I want to say, like, the VIPV is vehicle integrated photovoltaics, but of course this is a broad field. So Rupert was now talking about the passenger cars, where it's about color, emotions, banded, nice fitting modules. I'm talking now more about the commercial vehicles, where it's everything about total cost of ownership, or TCO. And the modules is flat and integrated. And I will do this from a manufacturer's perspective. I will talk then a bit about the solar module technology, what we deploy now, what we developed and manufacture, also for the vehicle integration, the concept of manufacturing, and how we achieve the reliability, and also the outlook, how we see the vehicle industry now developing going forward. To OPES, we started the company 2012, and we focused on customized solar panels for applications. We built our first plant in Jiangsu. Meanwhile, we have there 450 employees on 12,000 square meters and produce about 500,000 modules every month for different applications. It can be modules for parking meters, for small sensors, for forest protection, street lights, share bikes in China, and so forth. And we also develop the automation equipment for this sector. And in this sector, we learned also, we talked this morning in the sessions about the engineers and the architects who live both in their own worlds. And we noticed as well, when you make integrated photovoltaics for applications, it's also our own world when you come from photovoltaics, because this is, you are more becoming a component supplier. So the component needs to work and fit somehow in a housing, and the modules are sold per piece, not per watt. And it's very important how flat they are and where a certain hole is drilled and this type of things. And we followed the battery industry. And then since 2017, we figured out there's a lot of batteries on wheels going to drive around and becoming more. And that's a vehicle industry that is in a big change. And that's where we started with Fraunhofer ISE to develop solar modules specifically for this purpose. And we have, since 2 years now, had a site selection process where to do this. And we built a manufacturing site there in Zwenkau, south of Leipzig in Germany, which we recently just inaugurated and now starting serial production there. And on the cell connection, our decision was not to develop our own cell technology, but go with the industry standard, because supply chain is very important in solar, especially when you are a manufacturer. We are in Europe very small compared to what China is doing in the solar industry. So we go with wafer-based solar cells, but we start with our own cell interconnection technology, and that's shingle matrix technology, originally developed in Fraunhofer. We are commercializing this now. And it's basically, instead of connecting the solar cells with ribbons, we glue them with conductive glue, but not only in a string, but also in like a brick wall, basically, where you can have both serial and parallel connection of the solar cells. And this has a couple of different advantages. You get more power on the area because you have no space between the cells. And another effect is, of course, the thermodynamical stress you have when you glue a panel on an aluminum or fiberglass sandwich. The interconnection can be more taken. And also the shadowing behavior is much better. I will come to this. When you have fast changing shadows, it's automatically regulating in the module, and you can save money, for example, with MPPT tracking. So these modules are thin, very light, 3 kilogram per square meter, and can be then glued on the top of a truck. And you see on the left side a classical solar panel like we know it, in this case the butterfly concept, where you have the bypass diodes getting active immediately when you have a shadow. The beautiful with the shingle matrix technology is that the cells are glued in this way that if you have a certain shadow, the electrons can just flow around, and only this particular part will not be impacted. So it's like a natural MPPT tracking, and it's not only for shadow or maybe bird shits or something that can be on it on a vehicle. It's also when you have a small damage, the car bumped somewhere, only this particular area will fail, so the whole system will still work and continue to function. And we go also innovative ways in our manufacturing concept. Here you see our plant in Germany, in Zwenkau. Normally a solar module production, when it's highly automated, is only one module type. That's why the most modules we see, they are still squared and glass aluminum frame. They became a bit bigger because the wafers become bigger. But it's normally one type per line. inline production on gigawatt scale. And we need in Germany also to go to a high degree on automation, and but still needs the flexibility for the vehicle market. And that's where we found a concept to make fully automation with changing some settings. We can change between the motor product types, and the smallest module is a 90 watt. It's 0.5 meter times 1 meter. So this is for puzzling on a bus roof, for example, where is emergency exits and chillers and other things where we have to go around. Then there's 125 watts. It's known from the caravan industry very well as 110 watt. 165 watt is a Euro pallet type of size, because in most commercial vehicles, semi-trailers, also trucks, you have the same size like a Euro pallet also on the roof. So it's not more thinking behind it. And the 460 watt fits for all the push-up roofs on the caravan where you can sleep, like Mercedes Marco Polo is there the smallest one, but we are already in serial production delivering for Ford or Fiat. Ford Nugget or Fiat Columbus, you can order at the dealer already with the solar option. And then the 500 watt is the full width of a trailer. So that's our largest module, and 10 of these modules will give a 5 kilowatt on a trailer that then can work as a cooling support for the cooling system. In the vehicle sector, we have a lot of new requirements coming to solar, what we not used normally to in the standard industry. One thing that is different is the cost, of course. We have to look how fast it amortizes. So lifetime, we have to give a warranty of 10 years for the power. So it's also a bit different from the standard industry, how the lifetimes are there calculated. And we glue the panel on a surface, and that means I have to test actually also with the surface together. I cannot see just like the solar module in our own cosmos. I have to see how is it glued, which type of glue, what is the substrate material, and this all comes together then for the reliability. And I mean, testing we do there. We come to this one is vibration. But then the shading especially is important. We hedge this with the shingle matrix technology. There's tests that we normally don't know in solar. It's like washing streets, like what happens to the surface of the solar module when it drives 300 times through a washing street. Then scratches become important. Heat also, we get higher temperatures when we are used in photovoltaics. Normally we cycle minus 40 to 85 degrees in ISE norms, but in a vehicle market, we have to go to 95 or up to 100 degrees in the peak testing. Yeah, here you can see, for example, you can see on the left side, sorry, I was too fast, like the vibration testing, where we with certain frequencies test the model together with the roof, together with the gluing, and see what happens then to the EL classical part, where you can see is there cracks coming into the cell, and also are these cracks, and if they come, are they further developing, or how they are behaving, and how do they have impact on the module. There's a beautiful thing in the shingle matrix as well. For all of us that work detailed with photovoltaics, if we have micro cracks in a string, it can really impact the module and the lifetime a lot. But in the shingle matrix, the electrons can still work around these cracks. And also one observation, when the cells are glued in a matrix structure, the crack usually stops at the ECA glue tape where the next solar cell starts. And that helps a lot, because once there is an impact or you have a defect, it just is contained immediately when it reaches the next solar cell. And we work in a structure of 1/6 width of M10 wafer size solar cell. Yeah, system integration, there's different options from the shelf possible in the low voltage range. So 12 volt, 24 volt, also now 48 volt. And we have also been developing with a partner 400 and 800 volt version to really integrate into high voltage batteries. One challenge or barriers there still is in the market to overcome the interface with the battery manufacturers, that they cooperate with the solar in a high voltage segment. Very quickly, just some examples. I mean, the next speaker will have more of this, so I just say something to the buses. For buses, solar can play a good benefit, because especially when there's a hoteling and the bus is parking between the tours, then the whole system can be maintained. The battery is not extra drained, and also the standby functions when the bus is parking, they are not emptying the battery. So solar in many cases is increasing really the battery life by keeping the battery level up most of the time. Here you can see an example of the system with 8 modules on a rooftop and its installation. Another example, what now moves very fast, is integration on the driver's cab of trucks, because many of even in diesel-driven trucks, the battery sometimes after 1 year is already damaged when you buy a new one, because the alternator is not charging the battery fully anymore, only 70% due to the carbon regulations. And that means that if the driver still use a water cooker or something, he can very fast drain the battery completely and kill it. This I jump over because Ruth from IM Efficiency will say more about it. Just maybe to finish this presentation, how we see the development now in the different commercial e-vehicles and RVs. We are already in serial production for the RV market. The RV market, caravan market, no solar since 30, 40 years. But now the new thing is that we work directly with the OEMs or the car manufacturers to integrate already and not have it like an aftermarket with larger module types. Then the cab sets, 90 watt 165 is developing rapidly. We have the first truck manufacturers who already integrate an interface on the top of the truck where we can directly with the solar connect. So it becomes more and more for standard. Then there's the buses and smaller trucks where there's already some systems out there. And the trailers is now, of course, the most interesting one because it's most square meters. From a manufacturing perspective, the solar industry is a square meter industry. And there's a main case is really to support the cooling of the truck. And there's a big movement now on the chillers that are on the front of the trailer that go from diesel-driven to hybrid towards electric, because fleets have to fulfill their carbon targets. And their solar can play a very good role together with access recuperations and also high voltage batteries that come into the trailers. So thank you very much. And I look forward to the next presentation.
Thanks, Robert, for the interesting presentation. And we continue with Ruud Derks. He's the Chief Strategic Officer of EM Efficiency. And he has been 6 years at EM Efficiency, some other years also in building integrated photovoltaics. So yeah, the floor is yours.
I need to start with congratulating everybody here. You made it. The last presentation of today, so you made it. Some people left, I see. Really congratulations. We tried to make it interesting for you. So who is working in BIPV, really, in the solar world of BIPV? May I say and see hands? Okay. Who's working with VIPV? I see 3, a little bit hesitating. Okay, so VIPV, we are the new kids on the block. Yeah, so there is one poster about VIPV. But I need to tell you that there will be some changes. We were 2 weeks ago in Brussels talking with policymakers of the EU. They expect a lot of VIPV. And why? It's relatively simple, I think. You produce electricity where you use it. You don't have problems with net congestion or storage or whatsoever. You produce and you use at the same time. So that's interesting. So we are in trailers. Robert already said. How many trailers are there in Europe? Who knows? Can I get an estimate? Okay, nobody dares? Yep. How many? 1 million. Good guess. But it's 4 million. 4 million trailers times 32 square meters per trailer. That's a lot, I can tell you. There is a company, one of the main trailer builders in Europe, Schmitz Cargo Bull. They have about 25% of the market. They build a trailer every 9 minutes. If you stand close to a trailer of 13.6 meters, then you see how big it is. They make one every 9 minutes. So there are plenty of trailers. What we do is we use those trailers. We use especially the roof, and we turn trailers into a mobile solar park. That's our vision. Our mission is also, we make trucks love the sun. So trucks need to like to be in the sun. How do we do it? We add solar panels on trailers. We don't produce them. We buy them from either OPES or a red country in the east of the world. We add a battery on the trailer. So on the bottom of the trailer, we add a lithium battery. Why? We want to make sure that all solar energy we can produce, we store in the battery. And the big difference between a passenger car and a truck is, a passenger car is used only 5% of its time. Yeah? A truck is driving 50% of its time. Totally different. So we have solar panels, we have a battery, and then it becomes difficult. How do we get that energy either to the trailer, so many times there's a battery in the trailer, or we get it to the truck. And trucks don't like that as such. So that's what we focus on. So we focus then on solar. How can we maximize the solar production? We have a lot of data. So if I log in, I can see where our trailers are. I can tell you where the sun is shining now. I don't think in Florence, but... so we gather a lot of data. We are still thinking, what can we do with the data? So we heard a discussion about AI. What can we do? I would love to sell it to Google because we know where the sun is really shining. Is this new? We have 120 trailers driving around. So VIPV is there. Every week we add new solar panels to trailers. Main big transport companies. And you see some examples. I don't know, did Action already arrive in Italy? Yeah? It's a little bit rubbish sometimes, but it's impressive what the prices are. And most trailers have our product. You see even a milk trailer. You see a lot of Belgian Post. So it's all happening. On the bottom is one in Chile from Walmart. So a lot is happening. The complexity is that energy production by solar is there, but you need to use it. So we put it in a battery, but if you use more, or if you produce more, it's lost. So not like BIPV where you connect it to a building or a grid. No, it's lost. You can't use it. So it's good to size it and to plan it ahead that you consume it if it's produced. Difficulty is to find the right people because it's about solar, it's about automotive, and it's about electronics. We can't find those people. I think there are many solar people here, so if there's somebody working and interested in the automotive industry, let me know. I have a job. We make trucks love the sun. I have some data. This is the theory. So we have some trucks driving around with sensors just to know how much irradiation is there, really. So here you see a small truck in the front. On top you see a sensor, and on the side you see a small sensor next to the big solar panels. And then we really look how much irradiation was there. And the blue graph is from the top, the orange from the left, from the right, and the green from the left side. So you see on average, the sides bring about 50% of the top. Yeah, which is something, this is the Netherlands, by the way, so we don't get a lot of sun. Interesting, in Scandinavia, it's different. So percentage-wise, the sides bring more than the top. Here, it's also different. Percentage-wise, the sides bring less than the top, something like 35–40%, because the sun is higher. So we had an example, a trip from our small truck to Hanover. Hanover is the big truck conference every 2 years. So it went from a little bit south, then to the east, east upwards. And what you see then is that the orange is the right one. So you see in the beginning of the day, you see a lot of orange. That means that the right side of the truck gained most energy, which is clear because we started in September, we started in the morning, sun is low in the east, so the right side gets most sun. And driving back, it's even more interesting. So we went south, and in the morning, the left side was high. It was September, so the sun is already low, so the left side was producing better than the top. This is the best day we had with our small truck, somewhere in June 2024. And you see exactly that it's like BIPV. If you have the east, the south, and the west, everybody knows how it looks like. And the distribution over the day is great. So my dream is still, and we are building it, that we have a Google Maps where you get the best route, but that you also have a Google Maps which says, if you take this route, it's the cheapest because you produce the most solar energy. Some numbers, so we can deliver the energy to a diesel truck or to an electric truck. For a diesel truck, we are replacing the power from a generator. And with that, we prevent CO2 emission. Per truck, this is about 3.6 tons per year. 3.6 tons CO2 per year. Why? You win 5% diesel. 5% doesn't sound a lot, but if you know that the typical truck is driving 150,000 kilometers, it uses, say, 104. That's about 40,000 liters of diesel. If you then win 5%, that's about 2,000 liters. Yeah, so that's also the positive impact, the business case of diesel for a truck, as Robert already explained. For EVs, it's different. So in an EV, if you add solar, you extend the range, the maximum range, but you also give real renewable energy. There's a typo I see. Because if you charge from the grid, it's on paper, it's beautiful renewable energy, but in the Netherlands, it's about 29% renewable energy. The rest comes from coal or gas or what have you. If you get it from VIPV, it's 100% renewable energy. So we have graphs as many as you want. But I don't think that's so interesting. What we try to tell transport companies is what's the benefit of VIPV. There is a business case, a financial business case, but next to just less diesel or longer range, it's also that we keep the batteries alive. So a battery is very sensitive, especially a lead-acid battery. Battery is very sensitive. So we make sure that we treat it well, that we look at it. And so the lifetime of a lead-acid battery goes 3 or 4 times as long, which is also for materials, critical materials, very important. What customers also say that they like it for their marketing or PR. I'm a technical guy, so that's not so, I'm not so excited about it, but it's very important. So they also ask for PV on the sides. There are 3 main reasons why we don't put PV on the sites? Yes, yet. Who can think of a reason? Why no PV on the side of a trailer? Yep. Damage. The most damages of a trailer are on the side. That's one reason. Second. You need all of it, yeah, but the solar panels are only 2 millimeters thick. So that's not the real issue. Yep. Advertisements, that's the most important one. Stupid but true. They want area for advertisement. And the third reason is what I already mentioned. The efficiency of a solar panel on the side is much less than on top. Yeah, I'll keep it with this. My time is over. Thank you very much.
Thank you, Ruud. There are questions in the audience? Okay, if not, I have several. So I'm going to start. I would like to ask you, what are the specific characteristics that you ask for a PV module? Because probably many of us know the characteristics that this PV module that we are looking for building applications, etc. But probably the vehicles is a sector that, as we have seen, can be strange for many of us. Also, there are many people here that are developing bill of materials for modules, etc. So, yeah, maybe you can start.
For passenger applications, one of the most criteria is a homogeneous appearance. So every cell has to look like the next one. This is very challenging because, as mentioned, optics is before performance. These are the kind of, let's say, most important criteria. It's kind of the entrance card for the party. And then you have to, continue, and definitely efficiency and durability plays an important role.
Yeah, I think actually in the case of cars, most of us has been clients at some time. So I guess we can imagine how important is aesthetics, right?
Yeah. On the trucks and trailers, it's a bit different because as on the truck you cannot touch it. There's no haptics or color or homogeneity so important. I think I explained we go for the shingle matrix technology, especially when the module is bent during mounting, that it stays stable and keeps all the functions. But one thing is very important for us as a PV guys. It's also important to really look over the PV panel itself and see how it's, for example, glued and what is the material where it's connected with, because this impacts then a lot of tests that have to be done, for example, impact and others. And this depends very much how, for example, the glue is applied. It becomes suddenly important. And that might look boring for some of the, if you are in PV and try to get the cell efficiency up and are really as a PV module guy, like what we are, but we have also to work really on this substructures with other companies together. And that's very important for the reliability.
And Ruud, do you have something to add? To
be honest, I'm not a solar panel expert, so
okay.
They know better.
Okay. And what's about, in the case of trucks, what's about weight? Sure, if you have mentioned.
Yeah, weight is very important. But on the solar panel itself, we reach, when it's thin and flexible, like around 3 kilograms per square meter. And then we have this 30 square meters plus minus. So that's another 90 kilogram, but it brings 5 kilowatt. And you can easily then compensate by not having this battery capacity. So the battery is more critical on adding weights than the PV panel.
Yeah, okay, thank you.
And yep, here there are a lot of researchers, and I would like to ask you if you have, maybe it's related also with the previous question, if you have some comment or something that you want to let us know about the work we are doing, or the points we should focus for. Maybe it is also related with probably with the technical challenges that you are facing. You have already explained some of them. By the way, very interesting, because many of them were different that probably most of us have in mind from the building sector, etc., or just from the photovoltaic sector. So yeah, I don't know if you can have some messages for us, or yeah, some ideas, or
Yeah, I think you can theoretically perfectly optimize the panel, but really look at how the panel needs to function in its environment. And a truck is a terrible environment. So it goes up till 90 degrees or something in summer, especially in Italy. It goes -20 or -30 in Scandinavia. There's always storm. A truck is driving 80 or 90 kilometers per hour, so it's always stormy. There's wind, there's snow, there's everything. It gets cleaned every 2 weeks by a cleaning suite. So think of how a solar panel is treated on a truck. It's a terrible job. So when thinking about optimizing, or keep that in the back of your head, please.
Okay, thank you. Actually, this is related with the standardization point that could be also a point that we can discuss about. Yeah, because probably the standards and the tests that are currently for photovoltaics are not enough for the case of, yeah, actually, you can also comment on that if you want. Yeah.
For the passenger cars, I would kind of highlight the topic. It's all about integration on the electronic side. So how to get it most efficient with the lowest cost, the energy to the battery. So this is the challenging part there. Weight doesn't play an important and not so important role in comparison to trucks. Yeah, so you have a factor of 4 more specific weight in square meters because normal mineral grass is used. So all about integration.
Yeah, maybe just, I mean, this is all the important things. Just to add generally, in PV, when I was still young on solar module sites, that was 70–80% of the system cost. This has changed dramatically over the last 10 years. So the PV panel is not the super expensive stuff anymore. And that means that other costs become more important in the calculations, like how fast is the mounting, for example, how can the glue be applied in the quickest way? And then if you work in research now with solar modules, at least that's what our researchers in the module design work with. It's suddenly very important how to make a junction box that's a hole where it's integrated into the vehicle can be made smaller. So we have a junction box where you can connect directly the cable tree with the connector into the module, because the installation becomes a very important point in the costs. And the same is also, you have to think about things like on the glue in the market. You can fix a module that lasts there for 20 years, but also have in mind if you have to remove the module for some reasons, not necessarily because the module is damaged, but there can be accidents or there can be problems in the fiberglass sandwich material where a panel needs to be removed. So spend research there. How can I have a bonding? And this is something where we in the solar industry are normally not busy with, but it becomes very important when you look at the module. You have to look at the total system and the cost in it.
Okay. I have a question also for the case of Lightyear, because well, one of the main advantages of including photovoltaic in a car is that you can have a more range. Okay, in the case of electric vehicles, but at the moment the batteries are getting cheaper and with more energy density. Do you think that can
jeopardize somehow this the photovoltaic integration in the cars if the batteries become very low, or at the end the customer will always ask for more range and probably a little.
I think it's good when the batteries are getting better and getting in higher energy density, and the price is dropping, below 100 or even far lower than $100 per kilowatt hour. It's even supporting the overall goal of kind of efficient solar electric vehicles, because you're saving weight. You can optimize, and every kilowatt hours produced with the solar modules is kind of extending the range. And if the system is more efficient, the solar produced kilowatt hours is delivering more kilometers of driving range. So it's a cycle of innovation which has started, and all the engineers are kind of focusing getting more and more efficient cars, and this is supporting VIPV.
And one more aspect also to add is like that there's some paradox on with increasing the efficiency and making the cars electric, and also in trucks and trailers, they also increase the standby consumption of these vehicles. And that is a problem in the industry, because your battery, if you have the vehicle standing sometime, gets drained by data that are there and system checks. And there, solar can really help a lot to bring a continuous inflow to compensate for that.
Okay, thank you very much. Just to double check if there are any other questions in the audience. Yeah, one question there.
Okay. Yeah, I was wondering what about the how you say it, the guarantees, because especially I guess in the truck sector, maybe one panel sometimes gets broken and you want to replace it. But if you look at the developments in module technology, well, we get more watts per square meter. So how can you guarantee that you can replace the panel without changing the whole system again?
Okay, I take it as a manufacturer, because at the end, who pays for it, and that's the manufacturer. So we give on our solar panels like a 10 years warranty on 80% of the power output. But there comes something to it that is very important. Dependent for the warranty is also how the module is mounted and what type of glue it's used. So very often we do also, we have already a lot of tests we have done already with customers, but we do sometimes even with customers individual tests for a certain vehicle. And we have the labs for it. So that's part of the module sales, basically, to also offer this capability. It's a bit different from the standard module industry, because we really have actually adding to a car surface or a sandwich the function of solar. And whatever happens there very often is this interconnection where the devil is in the detail, where you cannot say this is the solar module or this is the other reason. But I think from the learning curve we had over the last years, and also now with shingle matrix and so on, this is very good manageable in the vehicle sector, because in the solar modules we have no moving parts, and once you make them right and connect them right, then you know what's going to happen.
Complexity is indeed if you add a different panel. So then you have, you need to think about how to do that. That's obvious. Yeah, the MPPT and the battery and every electronics you need to look at and be careful. Yeah.
Well, okay. Thank you very much for the presentation. It has been very interesting, and thank you very much for the audience. Please, an applause.
Thank you very much, Daniel, for moderating this
very last session of the first day of this conference. Thanks also to the speaker, and congratulations, really, as Ruth said, congratulations for being here to stay with us till the very end of this first day. Now we don't want to take too much time to you. You want to also to enjoy the city, to enjoy Florence, a very beautiful city. But we would like to give you a few information regarding tomorrow. So tomorrow we will start sharp at 9 o'clock. So try to be on time, so we don't want to accumulate too much time or too much delay as we did today, even if we were very good and we are be able to recover part of this delay during the lunch break. So I was really happy to see that the discussion was there. I mean, there was really a lot of noise during the coffee break, during the lunch break, around the poster. So I'm really happy, and thanks to the organization for making this conference and to organize it in these ways. Thanks also to all speakers. I think we cover most of the pillars of IPV, discussing about PV, about building, about architecture, about agrivoltaic, about vehicles, and also we discuss about social aspect and the importance also to take care about natural landscape as part of our living environment. So tomorrow we will continue this discussion with much more contribution from other speakers. I hope to see most of you also tomorrow. So thanks again for being with us. And maybe, I don't know if you want to add something.
Yes, I wanted to tell you that we have been covering on the LinkedIn page of the project, Seamless PV. We have been covering the conference, so you may find your pictures, especially if you were a speaker, on the page. And we also have a Flickr album of the IPV conference, so you can browse for the pictures that might have you inside. And tomorrow we will be back. And again, please follow the LinkedIn page of Seamless PV. And then I think Francesco has some news about the publications.
Yes, exactly, especially for all speakers. So you can find on the website, there is a special page in where there are all information and template if you want to submit a full paper for this conference. We are closing some agreement with the APJ and Energy and Buildings. This will be launched in the coming days. We will prepare a special issue within the two journals. So we will really encourage you to prepare your manuscript, submit it to us. And then also in the coming days, we will send to all participants a survey that we also encourage you to fill in. It's a nice opportunity to give feedback and to us, and also to check if you are interested to contribute with a scientific contribution to the conference. I think we said everything. So have a nice evening and see you tomorrow.